Hello, my name is Chris Danis. I'm a KMP developer, and I'm doing a live stream tonight to celebrate my 2K subs. I usually don't do live streaming. Just I don't know. I'm not against it. I used to do a live TV show in Austin, Texas, for from 1999 to 2003 or so. So I took a bunch of live call-in calls on that show, and it was pretty fun. I enjoyed it, but I think we're gonna just relax a little today and listen to a little bit of a talk between Alan Kay and the conversation with the faculty and students. This was about this is in July, put in July of 2007. And the reason I keep bringing up Alan Kay is because he actually had a lot of solutions to a lot of the problems that we're having today with all this complexity stuff. All the maintenance and the maintenance costs, the understanding costs, the onboarding costs, the bug fixing costs, the monitoring costs, and all that stuff. It turns out that's the biggest part of this stuff, and where everybody gets the most frustrated. After we have the excitement of the the proof of concept and the MVP, then we put these applications into production using those same ideas, and then we wonder why these things don't go well and have all these problems and issues. So Alan Kay saw that problem when he was working on that small talk and that star, the Xerox star. He realized that this complexity thing is, and he kind of knew that from other experience from working on computers for a long time. He said that the scaling up of these ideas, they weren't scaling up properly. They had to switch modes, and people are very they don't want to switch modes from the hack it together to make this thing a manageable part, because it's not sexy, right? It's not sexy to make it manageable and extendable and understandable and onboardable, and that's not the sexy part, right? That's not the gee whiz wow, but that's the part that we live with, and that's the other thing where Alan Kay comes in with this thing. He's coming in from this like biological, anthropological, cultural standpoint. Even though he's hardcore computer programmer, like he's in the guts of it. He understands what's going on underneath the hood and why. But he also sees there's not been this push because we've gotten away with avoiding this. We've already gotten away with avoiding this problem of dealing with the unsexy parts of the applications. And so these applications are all built, without Alan Kay's input most of the time. So they're all. That's my thing, is I'm pushing on this chance. They're all open for direct competition because they were made in a way that if you make applications in a way that Alan Kay is talking about, you can take over these other companies, because their products are not designed to be able to take that from the start. It's always been an afterthought, and complained about, like, oh, the thing has been running for a year, so why is the problem now? It's like, well, you don't see the heroic efforts that went involved to make that happen, and how many people had to cut corners to do direct access for your performance metrics, whatever that is, or people get stuck on the performance metrics and don't realize there's another performance metric that's even harder and gnarlier and much more worse. All right, let's see what Alan Kay has to say. I haven't watched this yet, but I always love when he has to talk, because it does take a stretch to talk from what he's talking about, because he's talking about this high level stuff that he's been embedded in a long time, assuming that we understand what he's talking about. Now, after diving in and listening to many hours of his talks, I finally kind of like understand where he's coming to. And then Yegor Boryenko, if it wasn't for Yegor, which I go into my course, how to program from the ground up with minimal BS. If it wasn't for Yegor, I don't think I would have understood Alan Kay. But only after Yegor forced me threats of violence, that if I didn't look at this different way of programming, that I'd be forever stuck in this other realm of static access, which is basically procedural, and the complexity is going to be limited until we get the message that Alan Kay was trying to talk about when he coined the term object-oriented programming. It wasn't even about objects or classes or hierarchies or inheritance or code reuse or any of that bullshit. It was about messages. Everything's async and done through messages, through APIs that are solidly defined and for purpose, and then the messages are passed, and then you have inside there, you can have other things that are also, everything's done by message passing. So if you take that message passing paradigm, you can take it out of a single process and break it up into multiple processes, and it still will work great. And then you can scale those things if you set them up properly. So that's what the microservices was trying to come off, but they didn't give Alan Kay any credit. No, nobody ever mentioned him. Like, hey man, this microservices seems like you're talking about the same stuff that Alan Kay was talking about. No, this is different. It's different. It's like, no, it's not different. It's the same crap. Let's keep going.
Award winner Alan Kay.
Oh,
he's coming to visit us for our CS or for HS.
just with the audio.
But we figured while he's here,
That's not my side. It's bad audio.
he thinks about the
Typical.
current state of CS education and where it might go with CS education. And what we'd like to do is allow you to ask
Try and
questions.
boost it here.
He wants to pick our brains as well. So we kind of think we're thinking.
Yeah, it doesn't have the microphone on. Typical.
At us as well. Did you want to make a few opening comments?
Well, I think that maybe the,
He has one.
I have one,
That's
but
better.
maybe it's not on.
His mic's working.
That might be for the
Okay.
Computer people can't even get the audio right ever.
Sure. And I guess with two mics, we should have at least two opinions.
Yeah, AV guys falling down the job, guys. Come on,
think
get it
this one
together.
works.
Get it together, people. Look, you making the computer scientist stick with the stick with the microphone.
This will probably be too loud.
This is pathetic, guys.
Okay.
You could have cut
So
that
a
out.
friend of mine,
No,
Neil
all right,
Postman,
whatever.
who's written many interesting books about media, when he was a graduate student in the 50s, he and a fellow graduate student found McLuhan, who was just starting to write some interesting books about the ecology of interaction between human mental systems and the representation systems that they use. And they just, being graduate students, being the 50s, they just followed McLuhan around to see what he would do. And Neil Postman.
Yeah, so Marshall McLuhan, if you didn't know, is the media. The medium is the message. She's extremely important figure in computers and in media and in like his whole thing with the medium is the message is that the medium, what medium we're using to communicate, has a message inherent in it. And I don't know if this quote is attributed to him, but it should be. But the subtext of communication is confusion. So how that confusion is handled and how we can manage it has been a goal of humanity for a long time. So Marshall McLuhan was just calling it out. Like, we have these different mediums, and they're not going to be like the old past medium. They're going to have a whole other language, substrate, structure, all its own.
I have many interesting stories about McLuhan, but the one I liked the best was that when McLuhan would give a talk, if somebody got up and started arguing with him, McLuhan would never argue back. He would just say, well, how about this one? And give him another idea.
That is the type of
Because
argument.
McLuhan viewed what his job was to get people thinking about things that they hadn't thought about, or things that were paradoxical and thus maybe didn't go together, and McLuhan thought they should go together. But he actually wasn't trying to convince anybody of anything. So he called these ideas of his probes that were just, and I'm not sure, I think my opinion of computer science education in university, first, is not important, but second, I think whatever opinion I have is probably too limited to even put forth the claim that would be accurate.
Interesting.
I'll tell you that about 5 years ago, I started a nonprofit research institute called Viewpoints Research Institute, because I'm
talking about the audio. It was just like, guys.
finally just did not want to try and do research inside of a company anymore, and
Yeah, that's super hard.
the ARPA funding had the good ARPA funding had run out actually even before Xerox PARC had started in 1970, and the NSF has always been pretty chicken about funding computing, except for rare instances when somebody from our field, like Gordon Bell, went there in the late 70s, primarily to force NSF to fund the internet backbone. If he hadn't done that, we wouldn't probably have an internet today. So, But generally
That's accurate.
speaking, the funding situation is not.
Because all these companies tried to do their stuff, but it was all proprietary, and they could never launch it, and all these regulatory issues, blah blah. AT&T was like, and then Xerox kind of, because they were already doing defense contracting stuff. They were the only ones that were kind of allowed to do it, and ARPA needed this defense system, and these people seemed like the only ones being able to do it. So that's how it happened. It wouldn't have happened any other way, and it had to be like a public thing that was available, nobody owned directly. It was a government thing, right? And then eventually, like in the 90s, they eventually let commercial enterprises access the internet, which they were already doing before that. They didn't care, but they got permission. That's when the floodgates opened.
Been good. Now, to most of the people in the room, the funding situation is normal because you grew up in that funding situation. And to me, who started in the early 60s, and we knew, believe me, we knew things were good in the 60s and the 70s because they just really were good. And even though it was normal for things to be good. But looking back now 25 years to the end of this, sort of in the late 70s, just how good they were in the 60s and the 70s was astronomical compared to.
Well, it was a conflation of a bunch of things, right? We were just coming off the back of the Cold War and the space race, which the government pumped billions of dollars into educating and getting kids involved with science and math and electronics and radios and rocketry and everything that's all involved. Like, there was a whole class, like a whole cadre of people who were into this stuff. I'm living in Mexico right now, so we have a festival in San Jose right now, so that was some fireworks. So you might hear some fireworks. There was a conflation of a confluence of certain events that allowed, and then so that space race was turning into this like flower power, creativity, LSD thing that was all related together. It was all interwoven. So it was like doing a network to survive a nuclear war, and also at the same time they're trying to do mind control. Maybe they're thinking about doing mind control because the MK Ultra was happening all through that period, and they're trying to find out the depths of the human mind, what could be controlled, what couldn't be controlled, and what could be like. And they're also doing all this fake news stuff. They're doing like lots of operations all over the planet. So, and it was running by these guys who thought they were doing the right thing, which who knows if they were doing the right thing? It's so unclear. But a lot of these things were happening all at the same time. So there was this vibe in the air, and he was able to, because of his personality and his precociousness, he was able to collect these things at just a brief moment, and they went for it. And that's what the technologies we're using right now and all these things. That's where it came from. It wouldn't have been for him and that vibe at the time, and there are a couple other people like him. We would still be, computers would be still somewhere in, there'd be 7 of them, and everyone would be logging in remotely by a terminal, running batch programs if you even had access to it. So that's why Alan Kay is like, we owe him a lot of thanks
to what we have now. So there are many. And I believe that a lot of the problems in computer science education have to do with scale on the one hand, the commercialization of a lot of inventions that were done in the 70s, and hence a lot more jobs. The nice thing about computing in the 60s and the 70s was you couldn't really make a living at it. And so it attracted people.
Right. So the people that were attracted are all adventure-driven, which I go in my series, the adventure-driven development. He was definitely adventure-driven. There really wasn't big money, and if you really want to get money, you go to defense contracting, right? That was the 100% guaranteed success if you get involved with any of that Raytheon or any of that stuff. Yeah, but so he was going off on this weird trail that nobody was paying attention to at the time. They thought it was silly. It was a little bit like pictures on a screen, really. And he's like, dude, this is going to be the way we do things from now on. As soon as you guys can get your head out from just doing paper copying. But he knew that probably was never going to happen. So he knew he only had a brief moment of time, 7 to 10 years max, to do this stuff and get it pushed out into the psyche, into the vibe, which we're all running on that stuff now. But also, we're not running on that stuff. We're running on like a bastardized version of what he was referring to with this Unix stuff, because he was doing Smalltalk, which is a whole operating system where the bottom to the top was live. You could recompile it at any moment, any part of the stack at any moment. Sort of like how JavaScript has the prototype chain. You just add to it, modify it, change it. In fact, JavaScript is very much the only small talky mainstream language because it's self-modifying. You can change it underneath. Now, if it was actually written in JavaScript and you could actually modify the JavaScript. Now then that would be the full small talk. Let's keep going.
Actually interested in computing.
So we still haven't seen that yet. We still haven't seen something like that yet. He's had demonstrations of it, but it's been like an app running on Windows. It's never been the operating system. That was it. Boom. It was always running in this other ecosystem. So we haven't seen the full computer revolution yet. And we will. It will happen because it's just the natural path. It's like when you look at the paths that are available, there's always like there's only a couple ones that are available. If you don't do this message thing, I mean, what else are you gonna do? What else are you gonna do? Like we're using AI to do static references. How about you can do that on the fly, just in time, while the program is being written or how the structure of the program is like. It makes it too difficult. And you're just using AI to manage all that stuff. Nah, man. Why don't you use this stuff that he talked about? Watch the stuff we talked about with Alan Kay. Everything's inside of messages. But there's a performance. I know. There's a performance barrier. I mean, yes, it's more jumping. As I like this example of like, yes, ordering a sandwich versus going to the store, jumping over the counter, putting the meat on, picking your meat out, picking your vegetables out, slathering on your stuff, putting the bread together, figuring out how much the total is, paying yourself, taking the change, and jumping. It will be faster than you waiting in line. Yes. But that's the whole problem is you have to learn every little task. You have to manage every little thing, everything. We're trying to abstract. We're trying to abstract that shit. That's what we're trying to do with computers. We don't want to do everybody's job. We don't want to know everybody's little job. I know some of the autists, they love to know everybody's job and they're the most valuable thing of the company because they know where all static references are at. Well, that's why we're having problems. Maintaining these things, understanding these things, upgrading these things, debugging these things, monitoring these things. Yeah, without this messaging thing as being primary, we're never gonna get out of this mess unless somebody else could get something in the comments. There's another way to do it. That nature that gets around the thing. Nature's like this seems to be the only way we can really have things working properly is have these segmented things and have chemical transmitters of all the carriers as well. Messages, basically, all these little packets all coming through that make us a living being that we get to totally we don't even have to know how this thing's operating to use it. That's what Alan Kay is talking about.
And most of these people actually had considerable training in disciplines that were well established. And so their bullshit detectors were very, very good.
Right, they're multidisciplinary. And they also realized that there was a golden moment when they had a limited amount of time. Let me make myself a little bigger here. They had a limited amount of time to do something like this. And that they were either going to go for it and enjoy it while he was here, or they're going to miss out. And the whole thing was this collection of people that he collected together. Like, there are guys like this every once in a while that come along and they collect these personalities around his personality and the vision, general vision, and how it's created, how it's made. That it can be like these little, I guess he calls these fireflies, where the people can go, oh, I see what you mean, and then go off that direction. It's like, yeah.
I think computing has a real problem in that I believe it's not yet a field.
No.
When Perlis made up the term computer science, he meant it as an aspiration. I think it was a great aspiration. I think it was getting...
I think it should be a branch of psychology. If that, I mean, I don't think it's really... I mean, there's this computer engineering, which is all the hardware and the circuits and all the digital stuff. Like that might be one thing, but then there's the computer sciencey part, not the algorithms, data structures. That's like the mind's like how to use a file cabinet. It's like, what do we kind of build to bring it? What are we building with these file cabinets to what kind of service are we providing customers? There's even more of that, like psychology, behavior science, that kind of stuff, like how people perceive the thing that you want to do and how to give it to them the easiest way and how to talk to them properly so we can hone in on what exactly they want for that particular niche that we're going into. Let's keep going.
I don't think we don't have some of the normal positive trappings of a science. So I don't think that has happened yet. And there's an infinite amount of detail that we can spend whole college careers learning without learning anything particularly interesting or enlightening or forward-looking.
Yeah.
So I think that is a real problem. And there's nothing like detail to attract people who design curriculum. Right. So go to a neutral ground. If the problem were music, a curriculum designer with the charge to design a curriculum for everybody in music would undoubtedly pick something like the C major scale to teach, because you can test it, can be memorized. It has nothing whatsoever to do with music. When I was learning,
So his point is like some of these details people get mired in, like data structures and algorithms, are kind of missing the point. Yes, you gotta know how that stuff works. Yes, useful, but it's not as important as it used to be. But the concept of the data structures and concept of algorithms, yeah, you should take a couple weeks. You should take a month and learn them all. Learn those major ones, like the 80% ones. Yeah, of course. But and then realize that's how the machine does its stuff, how it sees how it efficiently does its thing, and then how do you apply that to whatever what are you trying to do? Who for who? Why? What nuance do you bring in for your niche, for your thing you're trying to the thing you're trying to put the thing you're trying to provide, the extra, more fun, cheaper, fun, faster. I don't recommend cheaper. I think there's always showing something faster, funner, more interesting, more suited to the purpose. Yeah.
to play pipe organ at UCLA in the early 80s, I got to watch the performance major at UCLA being phased out in favor of musicology. And the reason was not even UCLA, but the entire University of California wanted papers. They wanted certification that they could look to nationally, and you could not write a lot. There's not a lot.
Yeah, that's the bureaucratic creep that all these organizations have gotten has happened to them, which is why they're all open for direct competitions because they can't move. They're all stuck in this. They're chasing their dog chasing the wrong rabbit. They're just chasing a skunk. They should not be chasing the skunk, because when they catch that skunk, they're not going to be happy with what they get. Let's keep going.
You can write about performing. So there's this great story about Schumann when he played a piece and somebody came up and asked him a question about the piece, and Schumann sat down and played it again.
That's it, man. Yeah, that's it. What do you think about your program for your Sluice? Well, did you go through the sequence and do it? Because let me know after. How do you feel about it? Are you my customer? Do you give a shit about what I'm doing? And write a paper about your customer. It's like, well, did the customer buy it? Are they arguing with me? They want a refund? Or come on.
There's a great line attributed to everyone from Stravinsky to Frank Zappa that talking about music is like dancing about architecture.
Yeah.
And so I think that the Marvin Minsky said in his Turing Award speech right at the beginning, he said,
he's an early AI. Marvin Minsky's an early AI researcher. He's got this thing called Society of Mind and some other things about artificial intelligence. Who knows if it's right or not? I haven't seen many things. I haven't seen any AI models coming from him, but he has some interesting ideas about how our minds work. Yeah, that's for sure.
The problem with computing today is an obsessive concern with form over content. That was
Yeah,
in
yeah.
1970.
Yeah, the form of it, the structure of it versus what are you trying to do with this damn thing? Oh, I don't know. We got the most efficient assembly language programmer. It's assembly language compiler. It's like, okay, but what are we making with this thing? Well, it's just compiles real fast. I know it compiles are fast, but what are we making this thing for? Who? Why?
Sound familiar? So I think there's been a lot. Neil Postman's great book more than 20 years ago was called "Amusing Ourselves to Death." It was public discourse in the age of show business. It's a very important, very good book. But if you were to write it today, you would call it "Distracting Ourselves to Death."
Ooh, yeah, there we go.
Because there's so much more that we're supposed to attend to, and we have fewer resources to reject stuff in favor of what we should be working on. So
well, some people. So that's the thing about this media. You have to see who it's designed for. I know it's hard to figure that stuff out, but like you have to look, who is this designed for? If you're digging it and you're feeling it, whatever, but it's like it keeps your mind vibes low. It's like, what? Why? I mean, okay, then that's for you. But if it's annoying, if you look at it and go like, oh, man, what is this? This is annoying. It's like, okay, well, it wasn't designed for you. It was designed for another level. If you're listening to me this far on this channel, you're probably at a different level. It's like, nah, I'm looking for something. I'm trying to See what I think I figured out at some point is like solving other people's problems. Not only is it profitable, it's super fun. Like especially if it's like a niche that people there's not very many people in, but you're into it and you or what you have a certain take on it. It's super fun, man. Really, actually makes life super worth living. Before, like, so I was into the computers way before there's money into it. It was thought out as so in the '70s, like it was thought of as like Magic the Gathering or radio controlled planes or something like that. Something like geeky, technical, but like superfluous, like AD&D, Advanced Dungeons and Dragons, all those role playing games. Also, it was just like nerdy, geeky. Like why? That's how it was seen. So it's like I'm a professional RPG player. That was like there may have been like some of the people, the authors maybe could get away with that of these games or creators of these games, but like everyone else is like just doing it for fun. And that's how most of it was until the was it 2000s or so when it just like mid 90s 2000s when the internet took off. Oh my god, that's when it was like everybody and their mother came in and it was just a big money grab at that point. But so I've been seeing this whole thing. I've and now it's like this lull again. It's like, oh, it's just over. It's like not over. It's not over. It's never been over. It's always just been a it's kind of a thing that if you're gonna do it anyway, like if you get off on like I don't know when you if you have the ability to solve a customer's problems in a certain way, and you're doing that one-on-one connection, that's just a great feeling, man. It's just it's and if you get paid at the same time, that's awesome too. But like I don't know, that's where my head's at.
So it could be that computer science education in the U.S. is okay, and I'm just completely missing it.
It hasn't changed since I went to school. It's bad, man. They really have fallen down. I think it's just because there's so many trade secrets and so much money has been in this thing that they can't let academia let some of these techniques about how these things are put together and make them as an emphasis because it's bureaucratized. So as soon as they in the '80s they thought they discovered everything there was to know about computers, they bureaucratized the whole program and it's stuck and it's definitely not academia is not where it's at. This is on your YouTube in GitHub trying to at these businesses at these companies, open source, just people dinking around. That's where it's actually all that stuff's the edge of it's always at. Google's not even doing it. They always acquire companies. Come on.
But boy, when I started looking for researchers for this group, and we finally got some great funding last year from some unexpected sources.
That's cool.
ARPA, old ARPA without the D level funding to do a project that has almost no chance of success, and it's going to take us 5 years
That's great.
to fail. I naturally
He's got a very like sour attitude because of all that stuff that happened with Bjorn Stewart. He took the object coordinate name, took it off this other course, like took his thunder. That honestly, I mean, yeah, I get what happened. I understand why, but like, we're still with Alan Case. He's so dour and sad. He's like defeated right here because we've been like stuck in this little whirlpool and like trying to make everything super optimized faster than heck. And then it's like the machines are fast enough. Now it's this other thing that we have to deal with, this maintenance and understandability and complexity.
We looked for people that I thought would be the right kind of people for this, and I can tell you that virtually none of the people in the group so far that I found have been American. Now, the good news about the internet is it gives you access to everybody in the world, and I've had to go pretty much everywhere in the world to find people. Person from Brazil, a couple of people from Japan, a couple of people from the former East Germany, and we have some Americans in it. But what it was striking that the outlook is what you need when you're doing research, because you really don't. The whole difference between research and engineering is in part that engineering you're supposed to apply what you know because you don't want that jet plane to fall.
Yeah.
You just absolutely do not want any scientist or mathematician designing your airliner, because they're even happier if it falls. You'll learn something. You want serious pens in the pen holder engineering when you're flying on that plane. And I don't know if you ever contemplated that jet engine that's out there. I love jet engines, but the more I found out about them, the more I wound up loving them, because I still fly. But it's amazing that they work, and it's amazing that they really work. They're just amazing pieces of technology. And
for sure.
But research isn't like that. Research, you're basically, at best, trying to get the tree to fall in some direction so you can run along the trunk for a while. And so you need people who have a very different outlook about things, and essentially people who can be profoundly dissatisfied without getting the immobilization of depression.
That's him. That was his self-description.
That's what researchers, and most art has that characteristic. Successful artists are profoundly dissatisfied, but they found a way of getting past just being depressed.
Yeah.
So they have a feeling, and sometimes you can convert depression into anxiety. Anxiety works because you're active when you're anxious.
He's telling it how it is. This is his motivator. Let's keep going.
So basically, you're looking for people that, and it didn't seem like the U.S. is turning out that many people, and certainly not university people. The Japanese that I got were not Japanese from universities. They were from the counterculture in
The adventure-driven guys. Mm-hmm. Yep.
computing in Japan, which is awfully interesting and awfully good, but not a product of the Japanese university system. So I guess and I'm also an adjunct professor in a bunch of places, so I've had a chance to look at what's going on and occasionally teach a course in university. And
That's
my
cool.
impression is that it's not whether the kids are smart enough. This is something, smart in a sense is easy. But imagine if you had an IQ of 500 and were born in 10,000 BC. How far are you going to get? You're going to be able to outwit anybody. But take a look at Leonardo, who I'm sure is smarter than every single person in this room. But he couldn't invent a single engine for all these vehicles that he wanted to make.
True.
He just was living in the wrong time. It doesn't matter how smart.
He had the applications, but not the source. Because that source, let's be honest. Figuring out how that engine worked, man, there had to be a bunch of technology. You had to get that lathing technology. You had to get the material technology. You had to get steel. Then you had to have all this precision. You have to have measurement instruments and tools to do the precision, repeatedly do the precision, because you had to repeat these parts over and over and over again, and then the sealing them together, so they had to be really precise. And then figuring out the temperatures and the compressions and the amount of fuel and the kind of fuel and how the carburetors and all that stuff was man, years and years and years of many men, and they were all doing that stuff. I don't know of any women. I've never heard of any women doing any of those engines, but getting those engines to work, and so many people did all kinds of crazy different designs. It turns out that the piston was the one that worked. And the rotating, it's and then getting all the timing with the spark plugs and the magneto in the beginning when they had the magneto thing. I was and then if you look at the original Model T, how many controls it had just to get the fuel air combo right, and the choke and the, oh, jeez.
Smart you are. And so I think the smartness you're going to find, and knowledge obviously dominates IQ. But in fact, people have been knowledgeable for 200,000 years about something. That's why we survive. We have cultures for knowledge.
And he says, so knowledge dominates IQ. So the more bits of information, I think that isn't true in my case. The more bits of information, the more stuff I see, the more I can categorize in my own mind what these things are without having to. I'll let somebody else do a little bit of thinking about those things, and then let me recategorize myself. So yeah, maybe, I don't know. I would like to see some studies on that.
Every culture is loaded with knowledge. So I think the most important thing is outlook or perspective or epistemological framework.
Yeah.
Those are things that schools should be teaching.
Should be. How? Who's going to teach that? The culture doesn't have that stuff. Or maybe it did, or there's a subsection that did. I remember growing up, it was definitely a thing. But how would you get the bureaucrats to standardize that? We're going to standardize thinking outside the box. It's what idea? How would you even do that, Alan? Let's keep going.
So the basis of Montessori education, she said, the number one thing we should be doing.
Which is all changed now. His stuff that he was talking about was the real deal, but that's all different now.
Young children is getting their common sense to be the common sense of the 20th century, not the common sense of the 11th century.
Yeah, my son went to a old school Montessori school, and they have all these little tools and little toys and stuff to learn about counting and sorting and all this cool stuff. And man, he loved it.
Right.
My son loved it.
And so that is the most difficult thing to find when you run into a high school kid or a college kid. Their common sense couldn't be more like a cave person.
Right.
And, yes.
I don't want to distract you, flow too much, but
please.
Just to clarify to this audience, we do research. I mean, there's thousands of computer science conferences. We put out PhDs every year. Those PhDs go to these conferences and present their papers. We're very successful at doing that.
Yep.
But
In the bureaucracy of putting the papers that are confirmation bias, you try and do something outside the box like Alan did. They're gonna try and shut you down, shut you up. Oh, take your words. AT&T, Beyond Stewardship. Take your words. Take the concepts. Re-promote them. Rebrand them. Don't give credit. Yeah.
and producing brilliant researchers and all the other universities doing the same thing. But you're saying they're not the people you want for what your approach you're taking, that you need to go somewhere else.
Well, what do
so
you-
maybe you could just tell us what
No,
it is that you're...
I'm more interested in hearing what. I'm really happy that you broke in because I will talk forever.
Okay, I'm just trying to put...
Yes, he will.
Yes,
he will.
And the
Okay.
fact that what we do is...
Well, here's what I-
there's
what
an
I-
established field of computer
Okay,
science.
so when I come to a university, here's what I see is, in fact, people have them right now with them, but when I go into offices and go everywhere, with just a few exceptions, I see people trying to do, presumably research has something to do with the future. I see people doing their computing on machines of the past and software of the deep past.
Yeah.
And that's quite normal to people. It's not remarked about. But you have to realize when I was in...
Remember now, this is coming from a guy that like put together the Star Xerox thing from the ground up, a whole language, a whole new graphic operating system, whole new networking system, whole thing. He's like, yeah, he's like, so when he talks about this, he's talking from experience. Like, no, you don't understand. You can build a whole thing from the bottom up. You don't have to. You don't have to use this old stuff. Why are you using this old stuff? You should be, if we're computing research, we're building bottom up. Let's keep going. That's what he's talking about.
School, every university of any note made their own computers.
See, I knew he was going to say that. I knew it. Because he's throwing down the gauntlet. He's like, hey, guys, y'all are slacking on. You're still using the stuff I did. It was just our first try, retards. Come on. You gotta step up. It's because this stuff that we're using wasn't ever meant for this. It was just a demo. It was just a demo to show what's possible. Not, we're going to use this as a baseline to build on. No. This is what he's trying to say. He's like, no, we have to... You guys got to build your own stuff, man. You guys got this computer engineering people. You got your OS people. You should be building all kinds of crazy OSs, all kinds of different hardware. Not trying to copy something new. Intel chip. Make your own chips. Why aren't we making own computer processing chips? A whole new thing. It's possible to implement what Alan Kay was talking about now. So we haven't seen the Great Revolution yet. We're still waiting for it. Let's keep going.
And the students helped make them and design them, and the students helped make up new operating systems for them and write them.
Yeah, man.
And today we live in a time when it's easier to make a computer than ever in history, and yet I don't know of a major university which is doing anything like that.
Sad. No wonder this shit stalled out. No wonder this shit has stalled the fuck out. None of them are doing that? Okay, yes, that's why the university system's got to go away. It's got to go. It's going to be something else. Something else will come up. Because they're falling down. Because that's what he's like, dude, we used to do this. This is not far out. This is not beyond comprehension. None of them are doing it.
Like that. And the...
Not grow our own food either.
Yeah, and what is that? That's an interesting statement, but I don't...
Well, building computers isn't interesting anymore.
Oh, yes, it is.
See. No, he's gonna go in for the jugular. Never get him, Alan. Go for it, Mr. K. Go for Professor K.
So let me...
How can we do that when we
Well,
find out?
let me give you two reasons. One interesting one is that Butler Lamson, who I think you'll admit is a fairly smart guy, took a look at the general computing resource at Xerox PARC and compared it, this was done a few years ago, and found that the computers of today are, in absolute terms, 1,000 times less efficient than what was done at Xerox PARC. And 1,000 is 2 to the 10th.
That's why we still have this thing in the future. We still have this to look forward to. Is the computer revolution will be 1,000 times faster by just using Alan Kay's techniques updated for today? Even 100 times faster. There's your performance.
And 10 doublings at a year and a half apiece gives something like 15 years of computing that we've actually lost. And so there's an old wives' tale that Moore's law and the Turing tar pit will make up for bad computing. But in fact, what you're missing, I think, just my opinion, is And what you're not curious about is why was Park so successful, and why has there been nothing quite like Park since then?
Yeah, all these billion-dollar companies. Oh, we're gonna just acquire everybody and ship them off in the back room, and okay, we'll pick off a couple of developers. They will still play along, and we'll just cash out the rest. No, we're not gonna continue on. We're not gonna do 1,000 Balloons Flow. No, that's too complex. It's crazy that these companies don't do, because this is stuff. You could have one Alan Kay and a center like that. It's just here's $1 billion. Figure stuff out. And don't do your bureaucracy crap. We don't want any papers. We want to see something. Make stuff. Makes new operating systems. Keep coming to pump them out. No, never heard of it. Okay.
That is, why is it so derivative today? And one of the reasons is that we made a computer that was literally 15 years ahead of its time.
Right.
And thus we were always computing. We had two things going with that computer. One was we made 2,000 of them. So we didn't make just one or two. It wasn't a demo.
I thought there was only 100. I mean, 2,000 is still a demo, but he was okay. Wow, I didn't know I thought he only made 100 of them. He made 2,000 of them. I mean, yeah, it was more than a demo, but it needed a lot of help. Let's be honest. Let's be real honest about it. It needed Steve Jobs in there, really. Yeah, it needs Steve Jobs in there, and instead that's what Jobs did. He eventually took people from this thing and brought them over to make the Lisa, but Lisa wasn't. It wasn't. They were trying to build it on 68K chips, and he's like, man, you got to do your own hardware. He was trying. It's like, we can't afford it. We need something out by next quarter. We're done. It's like, okay, Jobs, I understand. I get it.
It was actually a facility because we didn't want to be bound by vendors' thoughts of computing. And it wasn't just a faster computer. It was a different architecture.
Right, completely.
And so the two things that worked there were, first, we could try out zillions of experiments without doing any optimization.
Right.
So we could go out and drink a few pitchers of beer at lunch and come back and do a dozen experiments in user interface and never have to write a line of code that was optimization.
Right.
Because the Alto would just do it. So,
right.
So it was about 50 times as fast as a time-sharing terminal back then.
That ass.
Can you clarify what you meant by 5 times slower than reading?
He said less efficient. I'll give you another measure. I'll give you the measure that we did in just a second, as soon as I finish this thought. And so the other thing, besides not having to optimize to do a zillion experiments, this helped us a lot because for us, it was hard to have a good idea. The way we thought of it is, boy, it's easy to have mediocre down to bad ideas, but it's really hard to have good ideas because we just don't know. There's not a lot of principles that are worthwhile in computing. Therefore, we have to do experiments. And doing experiments without having to optimize was huge for us. Not just in the user interface, which is critical, where you're doing hundreds and hundreds of things and trying them out, but also just in programming languages and other areas. But the other thing that was very, very useful was that if we were willing to optimize something on the Alto, then we were writing code like people were going to write 10 years in the future. In other words, we could make an actual application that would be comparable to what was going to happen 10 or so years in the future. For instance, Microsoft Word was done 10 years in advance of when it actually came out, precisely because we had the computing horsepower to do that. So both of those things were absolutely critical to allow us to live in the future instead of the past. Everybody else in the country had computing resources also, but they didn't realize, like McLuhan has pointed out over and over again, that all of these things have built-in resources. Now I'll address your...
Built-in, I think what it means built-in concepts, built-in paradigms, built-in how humans approach the thing when given a thing, how they'll reach selling points about things they want to do and how they want to do them. And you can't find them. You can only like throw darts. Does it get close? And when you'll pop the balloon when you're close, like, okay, that's what's good enough. Yeah. It's an iterative process, an experimental process, an artistic process.
So here's a benchmark we did, which was more conservative, I think, than Butler's. Although Butler's a much more conservative guy than I am, so I was very surprised at his factor of 1,000. But we...
That's impressive.
It just turned out that our research for convenience was built on a version of the software we had done at Xerox PARC because it was easily portable. And so we had optimized it on Macintoshes and on Windows Intel processors with about the same amount of effort as we had optimized at Xerox PARC.
Right, but he was still running I'm in Mexico, so there's it's San Jose's St. San Jose's Day today, and the local church is the San Jose Church, so they're still throwing off fireworks. If you hear explosions in the background, that's what's going on. But yeah, I guess what he did for the Windows and the Mac later on was made an application that kind of ran Smalltalk, but it wasn't the full blown, all the way down hardware architecture like they had at Park with the Alto. I don't think it was that. I think it was this other just like little application that simulated that thing, like these Commodore 64 emulators or yeah, Super NES emulators you can get and just run on your laptop. I think it was that kind of thing. So we still haven't seen a full example. I don't think it's. I don't know if using. Let's keep going.
And so just for the heck of it, we ran some low-level benchmarks that we happened to have figures from back at Xerox PARC, and they were only 50 times faster. And when we worked through the various Moore's Law things and the clock speeds and the other kinds of deals like that, we thought, boy, there's a factor of 600 missing here somewhere.
Yeah, because there's that operating system layer. It's full of cruft and randomness and weird crap, and so you're running on top of that. That's soaking up all that Moore's law. That then your application, which isn't built, which is not designed for. You're getting some speed ups from that extra Moore's law power, but it's taken away by the operating system because it's doing all kinds of extra shit you don't need. Who knows? Shipping packets off to Moscow or NSA.
Where did it go?
Where did it
Butler
go?
has a talk that he gives. You should invite him here to give that talk on where he thinks it went. And but in
Obviously,
fact, if you
it went to the operating system and all the other crufty, random stuff that's in there that no one person can fully understand ever in a million years.
if you actually look at the thing in a finer grain, and actually I have a slide in it. Actually, the talks I gave in 2004, I even showed that slide here, showing that things really haven't sped up as much as Moore's law claims it is. Because, for example, the memory architectures today are abysmally slow. They have no correlation of any kind with Moore's law. Almost zero.
I didn't know that.
The caching is done so inefficiently.
Yeah, they never talk about the memory. They always talk about the chip speed.
In several different places today that it has almost no connection with any Moore's law. So there's a bunch of things that have no connection. And the Park hardware happened to be microcoded. And so we designed it explicitly for doing very, very fast virtual machines for very high level languages that would keep main memory busy. Not contending with main memory like any virtual machine that you do today, but it was these emulators were made so that they ran independently and much faster than main memory, and were able to, if you could keep main memory going, our theory was you couldn't do any faster with just gates. And so our whole approach was very different. And so the speed up is not a speed up in clock time, but it was a speed up in to the user time. And the low-level benchmarks are really surprising to me, because I would have expected those at least would have been faster. But in fact they weren't. Yeah, sorry. Somebody down here had, yeah.
So, two-part question. The first thing is, when you're looking for your team and you're trying to figure out who to bring in, what things are you looking for in them that would cause you to bring them in? And the second part is, if you were to create a school to train people that you bring in, what would you use to decide who should be in the school?
Well, the second one I don't know. The first one, basically, generally speaking, I've over the years, and the old community over the years loved intern programs, and partly because, for instance, I never would have been accepted into graduate school if David Evans looked at transcripts.
I know I wouldn't be either.
But he didn't.
Awesome.
Couldn't care less about transcripts.
That's badass.
And so he did look at resumes. If you'd done anything that was, if you had on your resume two things that were in direct contradiction to each other in some way, he loved that. And so after I got my PhD at that ARPA project, I was on the faculty there for a year, and I got a chance to see how they did it from the inside. And so Dave's theory was, anybody who's remotely interesting, let them in. Don't bother debating or any of that stuff.
And how different today is it from back then, when there was, okay, so a lot of the pressures back then was because you had this Cold War that people thought a nuclear war was about to fly off. We were exploring consciousness, and The outer regions comes with the flower child, hippie children, and LSD or marijuana was like a huge thing, like free love and divorce became a thing. We're just trying to figure out all the different ways, all this war looming over it, and we got to like try and find a way to live. And there was this like, what's the word? Uh, Anxiety, like this always constant low level anxiety. And that's why I was like, if somebody looks good, bring them in. If they're not gonna work out, we'll get rid of them. But like, we don't want to gatekeep. This is not the time for gatekeeping. This is time for letting people in. We'll kick them out if we want to. But that was a different approach. So now today it's like gatekeep, right? Leak code grinding. They don't like, we can't deal with having people in here in our source code screwing things up because you got to be 16 level 16 autists to deal with our code base. So they have get a lot of gatekeeping happening, right? So that's a flip.
Give them 2 years.
For different reasons, right? Now we're like, oh, it's not. We got the small piece of pie. We can't. We don't have enough. And also this whole thing like, the more pie, the more cooks in the fire, and the more cooks in the kitchen, it just gets really super messy. So there's this gatekeeping, and we're gonna. I see a time here, pretty future, where we're gonna have more people coming in with the AI people, independent programmers, independent companies, small companies, niching down and using these AI tools to directly attack some market space and have a smaller running operating costs and take that away, and using Alan Kay's tool set to manage your complexity.
And then get the faculty together, and just every single person had better know every single student. That was one of the rules at most of the ARPA projects. I think
Wow,
also.
That's pretty cool.
And Dave Evans and Perlis were great friends, and so
Just a different outlook on American life at the time, and a different way of seeing each other. It wasn't just as economic units. It was also this exploring. What can we explore our minds and get some solutions outside of the problem space that we're stuck in right now? It was like that impetus was definitely part of it.
Scheme here was somewhat similar. And then the faculty would decide whether this person was real or not after this 2 years. And if the person was decided they weren't real, they would fail their orals or fail their quals and be let out with a master's degree. And
nice.
If the faculty decided they were real, then they would go on to get a degree. And the way it
means PhD, I guess.
It was done at Utah was 2 years of top quality, world-class quality work advancing the field was a PhD as far as Dave was concerned. So if you were working on a really hard problem, you didn't have to finish.
Nice.
Because
wow, how different is that today, where people are told to like finish everything and make sure if it's slop, it's fine. Just all that matters is you finished. All that matters you got the certificate. Doesn't matter what you learned or your capabilities or how it changed you as a person. No, just get the certificate and you're good. And it's like, man, see, it's a totally different mind. So you can sort of see why ARPA was and Xerox PARC and Alan Kay's, he was the lightning bolt, because it was just so, his experiences opened his mind to other ways of doing things where everybody else was still closed down, holding everything in. Like, it was still that general vibe, but there was still more of this opening, and that's why this stuff is unique. It's all adventure driven, by the way. It's all this stuff is completely adventure driven. Let's keep going.
If you work on an easy one, so I was allowed, for example, to write up the work I had done so far on personal computing over the 2 years there, and I was out of Utah in 2.5 years. That was the way they did it. No place I've ever been a professor at, aside from Utah. I've been at Stanford, MIT, Caltech. None of those places would ever accept me as a graduate student, because it's more complicated the way they look at it. So
right, because they're more gatekeeping, right? They got a reputation, also the bullshit.
So to me,
they wouldn't accept them. So that's why we're not getting more Alan Kay's, because Alan Kay, he had a fight, and even then he didn't even get the credit he deserves. No wonder we're not having any forward progress. Industry standard.
Anybody who shows interest, like I've got this crazy guy who has been winning me over, who is a crazy Australian who's in Kathmandu, Nepal right now. But he found out about this project that we were doing he had worked on Erlang, and through the grapevine, this came, And this guy actually traveled to Italy when I was there a month ago so he could meet me and talk with me. And my thought, and this guy just doesn't look like the right guy, except that now we've got him for a 4-month internship, and now I'm thinking he might actually do it because, boy, there's nothing like motivation. My worry about him is that he might be too much of a hacker to work in our project because we
That'd be that's me. If Alan Kay hired me, that's what he would get.
have to do some deep stuff. And what we're going to try and understand about him in the internship is whether he has some feeling for deep. And if he does, by God, we're going to keep him.
Well, I mean, it's hard to get that out of somebody who's been, if they've been shown like, hey, you have to produce something, you have to produce something, you have to produce something. It's hard to get that because to go deep, it's like, okay, well, I might not be able to produce this. I may not be. I may only eat a little slice of it or a couple slices of it. I'm not gonna be able to finish this. And Alan Kay will be like, okay, go for it.
What is your project?
Well, this project is if you go to the So in that page, which has various recent writings, is the NSF proposal, which gave us half of this.
Make sure you get it, camera guy. Make sure you get it.
Project. We got $1 million a year for 5 years from NSF, and I found an even crazier funder for the other half of it. So we're doing it, and it's called Steps Towards the Reinvention of Programming, and it's not.
There we go. Ooh. Now nothing happened to this, I don't know what happened to it. It's been 10 years, 15 years. So probably nothing happened with it, but I love the attitude.
That easy to explain because
I like the title.
It's not the same as reinventing programming, but it's an attempt to get halfway up the mountain. The idea is we're so mired in normal, there's too much normal going on, that we need to do something.
He's talking about the C++ static access, non-messaging, class, hierarchy, inheritance, baloney, complexity, overly convoluted, random, crufty crap, normal.
Something to at least carve out a base camp that we might be able to see a little more about the roots to the top. And so in this proposal, I identified.
See, he's using the terminology with the adventure-driven development. That's exactly it, man. Can we make a base camp going up? Adventure-driven development. It's all about it. It's like, where's he? See, I know he's got the same mindset. That same. We need to. This is crap. We need to. There's something more. This is not it. There's something more.
13 ideas, most of which were not had by us, but over the years that I thought could be an alternative basis for an entire computing system.
Word. See,
Yeah,
he's always talking
when
about
Linda
thinking that.
Came along, I thought, boy, if Linda could really do pattern matching and if it really ran the speed of a subroutine, that would be really cool because then you would have publish and subscribe messaging. And if you had publish and subscribe messaging, you could actually have a very different basis for thinking about what programming actually is.
Oh, yeah.
And so that's one that's been on the back burner for a long time. And there was an AI system that was based on work done here at Carnegie, some of the Ops 5 stuff. It was called ART, Automated Reasoning Tool. It was done at a company called Inference, but some former Carnegie people. And I don't know, 15 years ago, another colleague and I spent a year trying programs out in this because it had a fast forward inference. And the forward inference on it was fast enough so you could do things that were like pattern matched, event driven stuff. And we became quite convinced that if you could actually do the next round of this, it would be a much better way of thinking about doing loose coupling.
Yeah, so what he's talking about here is like the microservices, just messaging, having an object send messages to other objects with a bus. So there's some sort of bus mechanisms, asynchronous. He's just repeated the same thing over and over and over and over and over. It's like, this is the way out, guys. And people are like, no, we can't do it. We already got something that's good enough. It's like, man.
Between large numbers of things. So that was just a thing that stuck in my mind about. And now, of course, the CPUs at Xerox were all microcoded, and the modern equivalent of microcode is field programmable gate arrays. And field programmable gate arrays are actually very amenable to 2 or 3 of just changing fundamental assumptions.
Okay, so now I think I figured he was doing like field program. So he was like compiling in hardware He was like basically compiling in hardware with it with a microcode, because that's like the little steps. And there's like a little steps inside of each assembly language instruction. He was like, but he's saying if we have do that in hardware, if we can do FPGA, some sort of technology allows us to freeze in hardware, we can run these things super fast, right? I think that's what his point is, which is true. They would be right,
Hey, let's
super
get rid of-
fast.
let's get rid of procedure calls.
Yeah.
Forget it. Let's try a different way of coupling, and we'll win if we can do it fast enough and the new way actually has something going for it that the old way doesn't.
Yeah.
So that's one of these 13 things in there. And the proposal is preposterous, as one of the reviewers. And I believe this proposal actually didn't pass review, though they won't tell me. I believe what happened actually is that they did have money. They didn't like the papers that they'd gotten. I was requested to write this proposal. NSF has never funded anything we've ever done before because it's too risky. And I think they just decided to fund it because it is preposterous. We have every chance of failing on the thing because what we're proposing is to start with gates and get up to the end user with something that is recognizably the entire personal computing experience in less than 20,000 lines of code.
Gnarly.
So
Well,
just saying, hey, we want a Moore's law.
I think we can. I think we can use his ideas and not his implementations. He's an old guy, man. We're gonna need some kind of new people to come along and go take his ideas, and because it's the ideas are sound. It's just finding a way to implement these things efficiently. You know, it's gonna take somebody. It's gonna take a risky thing that may or may not work out. Or it's just gonna take a while to figure out. So, or maybe some maybe already doing this, but I doubt it. Doesn't feel like it.
Increase in software expressiveness, and we want something that's 2 to 3 orders of magnitude less lines of code, and we want that code not to be cryptic. It's not writing everything in half-size APL characters, but to actually, and this isn't the same as reinventing programming, but we're going to have to invent a few things to make this work. And of the 13 things that are expressed in this proposal, a few of them we know how to do better than others. We've been doing experiments over the years. And this proposal found its way to NSF first as a white paper, because when I'm noodling about things, I like to write an essay about it and distribute it to friends for comment. So this essay, which is much longer than the proposal, has been circulating for a few years. And we had been doing experiments in the system we've done for children. We've done a lot of experiments at the end user end on how can you do an entire personal computing environment with just one kind of object.
Yeah, see, that's the stuff. That's what he's talking about. So implementing that idea is the computer revolution that we keep talking about. A whole personal computing environment as one whole thing, all that's modifiable. We haven't seen that yet. And that's, well, we have the Park, Xerox, the Star did that, but it wasn't what we expect this thing to be. You know, how we use these things now is still available. It's still in the future.
So it's just an infinitely recursible and unbuildable thing out of a much simpler kind of building block than the hundreds of object types that are usually
unbuildable. No, you can definitely build stuff out of smaller blocks like that you're talking about. So I think he's just saying like unbuildable now, maybe. I don't know. Let's keep going.
So this isn't starting completely off from scratch, but in the middle of this project, there are 4 or 5 of these principles where, you know, that cartoon that has the 2 guys at the blackboard and then a miracle happens. My favorite cartoon. So 4 or 5 out of the 13
Well, it does work that way, but let's keep going.
things that we've mentioned in there are of that nature. I could not tell you how we're actually going to make them work. But basically, in a 5, you know, this is a project that if it's doable at all, it's doable in 3 years. But the dynamics are if you take a 3-year thing and only fund it for 2 years, it takes 10 years. And if you fund it for 3 years, it's going to take 5 years. But if you fund it for 5 years, you can usually do it in 3. And the reason has to do with the kind of engineering you're actually willing to do early before you start making commitments. And so, you know, we asked for 5 years of funding, but if the thing isn't really convincing in 3 years, it'll be a flop.
See, adventure driven. See, he's freaking. See, I don't know why tech people don't talk about this. This is the reality of it. Yes, he's had such successes, but like also not level what he should be having, in my opinion. So yeah, let's keep going.
Right, that's basically the time. So, but I've tried to give talks about it, and
yeah, I think he's still holding on to the government should fund this stuff. these private companies really should fund them, but getting them to let go of their current existing technologies always is the innovator's problem, right? It's like how much do you exploit the thing you've been already spent money on versus spending money on doing something new that may wipe that out.
And it just doesn't fit that well into a talk, even though I give demos. So I think the proposal actually is the least confusing version of this thing. But I think you'll think it's preposterous when you see it. Yes?
In 1985, Alan Moore wrote a paper in which one of the things was billions of dollars for studying compilers and pennies for studying the programmer. In a rational science of programming, there might be more balance. Does that fit into your thinking?
Well, yeah, in the sense that humans are usually their own worst enemies about everything. And like, here's an interesting one. So I was a professional programmer for 5 years before I got interested in computing. I just
Legit.
learned how in the Air Force, and I put myself through undergraduate school and 2 other degrees writing programs for the National Center for Atmospheric Research. And
Nice.
so I didn't realize computers were really interesting until I accidentally found my way into grad school. And
That's cool. At that time, computers were super rare, so that makes sense.
I think the thing that, when I look back on that, and when I look at most programmers today, and when I look at computing today, the thing about programming is, if you're going to be successful at programming, you have to be good at coping, right? Because you're always working on, almost never do you have a chance to do anything from scratch.
Mm-hmm.
Somebody else's machine, somebody else's software you have to go on, somebody else's compiler, somebody else's blah blah. And you know what? The better a coper you are, the less good a programming designer you are.
That's true, because you're fitting yourself into somebody else's thing. Yeah.
Because the whole art of designing a programming language is partly being physically ill in using some programming language that you decide is ugly.
Yeah, that was me for Java. With the Android, brutal. At first it was great, but all the stuff they put it through, then you had to learn every little thing and that their implementation of it, which let's keep going. Kotlin's been a joy.
For one reason or another. And basically, if you're happy to cope, so one of the rarities of the people I look for, and the rarities at Xerox PARC was full of people who were awfully good at making things, but also were awfully good at being critical. PARC was a frightening place to visitors because we argued all the time. And the arguments were about why this is shit and why that's shit and why our own stuff is shit, everything is shit. And how can we get out of this shit? And so that's difficult. Today, it is very difficult to, if you complain today, first, I think the internet has done away with criticism in the sense that, like,
Except me, I'll criticize. I'll criticize the shit out of this thing.
Gresham's law, it's driven good criticism away. There's so much unfounded criticism on it. So good criticism, any criticism is put down as a rant.
That's me, a coder takes.
Because so much criticism does not have anything behind it.
Correct.
So I think it's very difficult to criticize, get away. But also, again, when I was traveling around in 2004 giving talks, the predominant attitude I had was a misconception about Darwinian processes, that most people I talked to thought that we must be at the best place that we could be, because look at how many millions of people are participating in this thing. And if you know about Darwinian
Yeah, that's that confirmation bias. Ooh, that stuff's deadly.
processes, they aren't optimizers at all. They're satisficers.
Right.
A term made up by one of the most famous professors ever to be at Carnegie.
Yeah.
And satisficing is not the same as designing something great.
Yeah, but most adapted for most adapted. Yeah, it's not most survived. Most adapted.
Great.
Most satisfied. Satisfaction.
No, I'm sure I elliptically answered it.
So Alan was advocating actually studying programmers and what they
Yeah.
do and how people think, to inform the design.
Yeah,
of
so I'm exactly,
languages.
okay, so I'm really glad you put it that way, because I couldn't disagree more. Because I think that, so the rallying cry for these high school teachers tomorrow, but it was also the title of the talks I gave a few years ago, was the computer revolution hasn't happened yet.
Yeah, that's what I keep saying.
And if you subscribe to that, then the last thing we want to do is do any kind of analogies and trajectories from what's going on today.
I absolutely agree with you. What the better word to put in every such program is your target programmers.
Okay,
Studying them and
yeah.
how they think and how they
Yes.
do it.
Well, then I couldn't agree more, because, well,
And I agree with you too.
no, it's just like, to me, the most important. So, Park is falsely credited for inventing the GUI. It's nothing
Really?
could be further from the truth. There are plenty
Really?
of GUIs in the 60s, but the thing that we did differently there.
Not like that though. With the desktop and all that, there was other graphical user interfaces. Yes, since the 50s. Come on now, but like that whole thing with the desktop pattern, the thing that we're using today, that was Xerox. Come on.
Was that all the GUIs in the 60s, almost, maybe with one exception, were command and control GUIs.
Yeah.
And as they thought of the purpose of any user interface to be like the panel of a nuclear submarine, or
Like a map with all the games that they've been playing on them for centuries by that point, like 1700s, 1600s, no. When was the first war game made? 1800s? So about 100 years of dueling out things on a map, and the map had a correspondence in reality somewhere, and then you just put that on the screen. Oh yeah, that's exactly where that came from.
or reactor, which is to give you access to functions. And it was expected that you would be trained to use these things as you are in those cases. And in fact, that has come back. That's kind of where we are, but in part because we included our users to be children. So we said it's not personal computing unless children can do it, because for the very same reason it's not a printing revolution unless children can learn how to read, and et cetera, et cetera. So because we're thinking along those lines, we thought, oh, it'd be more interesting.
Because it's not like they stay kids. It's not like they stay children. I'm so privileged or whatever that my parents dropped me off because they at the Boston Children's Computer Museum, and they just had randomly had a PDP 10 in the basement or in some side exhibit, and I just happened to run across it that when I was down there, and just happened to be given as much time as I wanted to play with that thing. Yeah, if it wasn't for that, who knows how long it would have been. Something I would have been a few years before I got more into computers. But yeah, I was a little kid. That's when I got into it. Nobody told me I couldn't. It was kind of like, here it is. You're expected to go do this thing. It's like I thought it was like any other exhibit. There, you had to push the button, do the thing. I was like, okay. I didn't know I was learning about a computer. It was supposed to be super hard to figure out. Okay, let's keep going.
Interesting, given that the very nature of a computer is to go beyond what it already has. So that if you can do something on a computer, that doesn't limit it. You can also do this thing, and you can do that thing, and many things are going to happen if this stuff ever gets commercialized. So our idea is, first and foremost, the user interface has to be some kind of learning environment. And because most of the functions that you're eventually going to get access to aren't even going to be there when you start. So it has to have some theory of how you learn these new things. And in fact, you could say that what's limiting much in the user interface domain today is that the user interfaces and the applications are so non-set up to teach people things that they feel like they're forced to use old conventions.
Right, you're using a convention that was devised to be as simple as possible and not flexible. So that he's just complaining that each one of these applications, you can't modify them and change them for your own purposes. You're given the application, use it, or submit a bug report. He's saying, no, we want to be able to, first of all, learn that this thing's going to fit in some sort of operating system that allows me to go in and change the stuff as much as I want, and have some sort of assistant thing help me do it as well. So I think that's what he's talking about. Or maybe not the assistant thing, I added that part, but I think he's talking about how, setting these things up to be like have idioms throughout the whole operating system, that if you want to modify this thing, you're going to have to do it this way. Maybe I think that's what he's talking about.
In the user interfaces.
But with the AI, with an AI assistant that's built into the operating system that could like assist with these types of things, oh man, then that's you're off to the races. Human directed modification of the operating system and applications, and there'd be pre-made applications, you could change them and without having to recompile them or understand all that junk, just in a natural way, and all of them are use the same thing. Yeah, we haven't seen that yet.
So it's only in areas like video games, for instance, where the children really want to use both hands, for example, whereas most adult applications are not two-handed interfaces.
Keyboard?
Precisely. Well, but I'm saying that that's a different way of looking at it. And the way I look at programming is that it is every much as important and in the same philosophical domain as reading and writing and math and science.
Reading and writing are a basic for having just a social, having a society. But the math and the science stuff, I think people should have a basic understanding of that. But like, if you're not going to use it, it's kind of people. Kids should be exposed to like building stuff with science and math to see if they're interested in it. Because most people just like, whatever, man, I don't give a shit. I just want to watch my TV show and eat my popcorn.
And that the main goal of education is not to try and produce professional readers and writers or professional mathematicians or professional scientists or professional computer people, but it's
That's what it's for, though.
designed.
That's how they treat it. They're kind of screening you for that stuff. Nobody tells you these things, but they are screening for that.
Produce people that are more enlightened than they.
Right. So this is the part I love about Alan Kay, is that he says we should get the more enlightenment stuff. Like we should be able to grow our minds. But the thing is, there's not only so many people. See, Alan Kay assumes everyone's interested in that, and most people just aren't. Let's be real honest. They don't want to know how things work. They're not interested. They don't care. I think you have to like get that spark early, or it has to be like innately within you to want to go explore your mind and challenge yourself in these ways and create things. I think you're kind of like born with this wanting to create stuff with your hands, and a lot of people just aren't interested in that. They have other things they're interested in doing. So I think there should be like an opportunity for this stuff, but like forcing other people, I don't know if it's. I got a lot of stuff forced on me that I just didn't make sense to me. I just was pointless, kind of cruel. Let's keep going.
They were 100 years ago because they have an additional set of ways of thinking about things and expressing them. Right?
Okay.
So that was the basic zeitgeist of what personal computing and networking meant in the 60s in the ARPA
That's true.
community.
That's the vibe it was coming through. This enlightenment, this mind extension, not a tool for working or social networking. It was like we're trying to like expand our minds. It was like that was the 60s LSD. Mind expansion, mind consciousness horizons, all different religions, different types of thought processes, and there's a lot of change going on. So he's still in that. Alan Kay was a kid when that happened, and it kind of sets up his whole structure to think that way.
That was the whole.
And it's like, why? Where did this go? It's like, what happened to this? This was amazing. He's like, this was incredible. Where did this vibe go? Where did it go? He's like, we need to bring that back. We're stuck, and we need to bring it back. Let's keep going.
Big deal from Licklider's first paper on, which was not about how computer people are going to interact with computers, but about how everybody is going to be able to enjoy an intellectual amplifier for their endeavors.
Well, see, at the time, that was the thing, right? But most people aren't. Turns out most people just aren't interested in that. But yeah, but the people that are, we still haven't had the revolution happen. We have only this first step to it. Our next step is still to be seen.
And so what does that mean? So from that standpoint, the last person you wanted to study is a person who does well at programming today.
Right.
Because
LeetCode code grinding.
By and large, they're doing well at something that was quite recognizable before 1965, including the amazing thing that most people still do system builds once a day, which I thought had gone out a long time ago. Yeah.
So what activity would you study instead?
Well, again,
Poetry, art, music, anthropology, play with kids. It's like, try and teach a kid something.
So people come in different flavors. To me, the most, and I hate to be prescriptive, but if there's one thing I would try and get every child in America to deeply embed from around 5th grade through the end of college, it would be anthropology.
There we go. See, I called it. Wow. I didn't figure this. Like me and Alan Kay are on the same wavelength, man. The computer, we don't give a shit what the computer does. It's like, these are for human beings. It's for us. We're not for them. We're not for it. It's for us. And the anthropology is like, okay, what do humans need? How do we act over time? What do all these different cultures have in common? What do we have differences? How do we best adapt our skill set of knowing how the machine works for people?
Because it is the best way of not taking yourself and your culture too seriously, or any of the subcultures you're involved in. I think it's the most important thing. And in order to understand modern anthropology,
or take your subculture seriously and know what's important to it and what's not important to it. I just keep thinking about Jira. I still have like PTSD flashbacks from that thing. It's like buttons all over, random radio buttons, check marks. What does this do? No, I have no idea. Are we using it on this project? Nope, never heard of it. Is there a way to turn it off? Nope. It's industry standard to have that there and not know what it does.
You have to understand modern biology. And modern biology is probably the best, well, pound for pound anyway, I would claim modern biology is the best thing that we should be looking at.
Right, because he's talking about the cellular structures, heavy cellular structures, which are basically a boundary layer that only messages from the outside have to come through this boundary layer, which is your API, right? And then the inside can have multiple little cellular structures all sending messages through some medium. And that's what he's saying. Like that's the only way out of this complexity issue.
As far as scaling and going from strongly coupled things to weakly coupled things. Remember, computers started out as being a kind of a 16th, 17th, and 18th century kind of idea, kind of like gears.
Correct.
Kind of like old style mathematics.
Right, because that's how they built it up. Those were the first computers where instead of using analog gears, all the little cams and stuff, and the precision was off for what they needed, they just wanted to redo that. If they could just redo that, they were cool. And if it was like a new machine, it was a software machine, and it was all running. You're building that machine up screw by screw with some machine language, right? And it was built for this one thing. It wasn't built for this other thing that Alan Kay saw that we've seen. If you've gotten this far into the video, yeah, it's this other thing now we're having issues with. The gear thing is we got that figured out. We got the compilers take care of that. Now this is like, okay, how do we deal with this complexity of having all these little things everywhere? He's like, dude, you gotta get the messages. There's no way around it. Let's keep going.
The algorithms are kind of gear-like, and the idea that you can smash values in data structures and get away with it, implies that you're thinking small.
Right, but that was where we came from. That's where the industry came from. He knows this. This is where he came from. This is the industry standard. He's saying we gotta let that go. That's not the important thing now. It's this other thing. This anthropomorphic, anthropological thing.
Right, because that doesn't scale. And so to me, the most interesting artifact
what he means it doesn't scale because you can't maintain it. You can't understand it. You can't onboard people with it. You can't monitor it. It's just, but it goes super fast. I know that was really key at that moment to do that. Understood. Now we're doing another problem. We have a different problem now.
From the 70s, and pretty much the only ones that have survived almost untouched to this day because there weren't alternatives were the internet and the Ethernet, both invented by the same community, the ARPA community that Carnegie used to be part of. And if you look at why this works, you see a direct contradiction in you can write down 25 things that the computing culture believed before the internet that are contravened by the internet, just in every domain. And it's a really good exercise because the thing you realize more than anything else is that a paradigm shift happened. And of course it happened in other places. And
well, we're still waiting for the full paradigm shift, but let's keep going.
And if I had to sum it up with a word, I had to come up, what am I going to say to the high school things? I would say that the ARPA Park research community, if you had to come up with one term for what they were thinking about, it was no center. No.
Right, because they were trying to do both at the same time, a network to protect themselves against nuclear war, preside for a nuclear war, and connect all these centers together, and these computers and people together in a new way that had no center. Because the no center thing was coming from ARPA and DARPA from the Defense Department saying you can't take our network, can't be taken out by some central location. We have to survive nuclear war, and that but Alan Kay was like no center, and he's like taking this hippie vibe thing coming through, and that's where the Xerox PARC came on. Was this we need to use these tools to move humanity out of this situation that's totally fucked with the nuclear war over our heads.
No center, which means networks are not star networks. You have personal computing. Everything is distributed. You have distributed objects, and the objects don't have a center. You have no programming language. You have no applications. You have no operating system.
Wow.
So all of those things were experimented with at Xerox PARC.
That's badass, though. But they tried to do it with no programming language. Well, they had to have some sort of thing, but I get it. Let's keep going. He's going out. He's going trying to stretch for these students trying to stretch their minds beyond don't think of these machines as they are. Think of what they could be.
Right. So yeah.
So the decentralized architecture is quite a romantic idea, and everyone seems to like it. And
it's hard to tell.
Huh?
The last time I looked at the task manager on my Windows operating system, I only saw 30 processes running. Am I missing something?
Well,
I would expect to see my little your little laptop there.
Right. He's saying these top level. He said we're just only seeing these top level opaque like objects. He says the 30 objects, but he's saying we should see the whole tree. But we don't get access to that tree. So he with the small talk and the Xerox thing, you could get access to the whole tree. You know, all the little things running, all the little things, everything, every little thing opened up where you can pluck it out and put it in something else. That's what he's talking about. That's what he wants. That's why he's like dissatisfied with this thing, with this Windows thing. He's like 30 processors. No, it's just like 300,000 on this damn thing, Nick, but you're not letting me see it. So that's why he's like trying to break through what people are know, and they go, this is a computer. It's like, no, this is just somebody's this is just a set of people's ideas from long ago, idea of how this thing's put together, not this is just the way it is. Come on now.
Is the equivalent of the entire internet in the 80s sometime, right? Computing, storage, processing power, everything. And when I look inside it, I would expect to see a few thousand objects with no center, not tied to any particular operating environment. Why should they be, right? What's
Well, let me ask
So,
suggest why. And like, because this 100,000 times less efficient, in absolute terms, is kind of bothering me. I mean, as a developer,
It should be bothering you.
about coping with legacy code. And
See, he's still complaining. Even back then, 15 years ago, legacy code has been the problem. The maintaining it, the understanding of it, debugging it, monitoring it, testing it, making sure it's freaking fit for purpose. No, we gotta make this thing together 2-week sprint. And then they were always like, oh, legacy code, 2-week sprint. Okay.
so, like, that seems to be, like, it seems that we can't, it seems like we're doomed to get mired in this proliferation of shit, as you were talking about earlier.
He's like, no, it's like, that's what I'm talking about. This is the issue. The main one is this maintainability issue. He's like, I'm telling you, like, we have to get out of this. This is bad. We're in a black hole. We need to get push out to some other, to get out of this thing. It's like this is not where humanity is going to end up with computers. Come on now.
you are doomed.
Well,
That's my
Yeah, we are doomed. See, like he agrees. Like this level, this kind of tech, this Unix stuff, Linux 50 years ago. Run out now. We're about at the end of this. This capabilities, like we've actually plateaued. We haven't really seen much advances in anything really. Just seen some more features, but nothing fundamental, which is what he's referring to. This fundamental next change of computing that will be available at some point. Hopefully in my lifetime, but who knows? Depends on you kids.
well,
But don't follow me.
Are you saying that we need a standards body to enforce
Oh.
A standards body, Jesus H Christ. He's like, yeah, it's like standards body. What the hell? Kids are going in the wrong direction. Pull out.
So they
go around and clean up everyone's bad designs?
no look.
Oh my God! Go around and clean up everybody else's bad designs? No. How we have to start with a whole new thing, bottom up, with his ideas to get a handle on this complexity.
So let me just sketch. So here's something. Let's take the internet seriously for just 1 second. So, and I love talking.
Look at that scar in his head, Jesus.
Nothing to do with it. I had something to do with the ARPANET, but the internet was done by colleagues of ours, and so it's not like claiming that Smalltalk is better than Java, which would be a bad thing to try and do. But since I had essentially nothing to do with the internet, I can praise it to the skies. And so let's just look at it abstractly for a second. It's maybe the only real object system on Earth where each object is an entire computer. There's
Yeah.
nothing more encapsulated than a piece of hardware,
Yes.
right? And pure messages are sent to it,
True.
really pure.
Mm-hmm.
So one of the most interesting things about the internet is that
Yeah. So we do have a living example of what the hell he's talking about.
if
Just the nodes that we're working with are not. We haven't taken that thing down to the next level of complexity by putting those things inside the machine. So that's what he's referring
object
to.
that receives a message is going to crash as the result of that message. It was its own fault, right? Because we're not sending 100,000 volts over the line there. We're just sending bits.
Right.
Those bits are entirely interpreted by the programs on that object.
Well, they're entirely interpreted and created by the programmers who set these protocols up that then get interpreted by that object. Let's keep going.
And the object gets to decide what to do.
So do you think every developer should be his own object?
No, well, wait a minute. So let me work it a little bit further. So then let's suppose we could do that efficiently in smaller things. These are the thoughts I had in 1966 when we were trying to think about some of these ideas. But so the thing I love about the internet is, boy, if I need something, there might be some object out there that could supply it. And
well, or some service. This is what he's talking about. So back in these days, so he can like object instance, some kind of service, some sort of some service boundary. So that's what he's talking about there.
might be able to be of service to me. I don't care what operating system it's running or any other.
Correct. We don't. He's correct.
Right? Because it's a pure messaging system.
Yeah.
So I may be doing one kind of thing, and that guy over there may be doing some other kind of thing.
Correct.
I don't give a shit. And so then the next thing I want to do is I somehow want to get as many of those objects in my machine as possible.
Right.
So the first thing I would talk to our friends at Intel about is, why don't you understand virtual machines? Like, the most important thing you can do on a computer today is confinement. So let's have it cheap. Let's use some of that memory that you're using badly for doing caching wrong. Let's use it so we can have thousands and thousands of virtual address spaces completely inexpensively on there. If you do the math on it, it's absolutely possible. It's just not architecturally in Intel's mind. Nobody's ever explained to them why this would be a good idea. Then all of us, and why don't we make inter-process messaging really fast?
Yeah.
Instead of really slow, the way Intel does it.
Right.
And all of a sudden, you actually start thinking, oh, wait a minute, I don't need an operating system.
Well, you still need whatever that thing is that's building that up, that substructure, that has to be there. Yeah. But what he's saying is like, you can get past, yeah, just keep going.
Because what I really want is facilities. I want services.
Yeah.
And I must have confinement because things can be dangerous.
Right.
But I don't want to rely
or charge money or have security access. It has an API. Yes, you have to. Everything goes to the API. Yes.
on software for that. I want real confinement. I want to be able to get anything from Timbuktu that looks reasonable, and I want to chuck it into a virtual address space and absolutely confine the shit out of it. And I want to do experiments with that thing. I want to feed it things, and I want to see what it feeds back to me. I want to be able to use it in various guarded ways, et cetera, et cetera, et cetera. These are not new ideas, but they are like magic if you try to explain them to Intel. Because Intel could not...
I mean, they already understand it from computer to computer, but they don't understand it inside the machine. Like because the operating system just doesn't support this stuff yet, man. I mean, we're going to need a new operating system for this.
Even get to the point of allowing programmers to microcode, so you can do higher level languages. So what I'm saying is the level of...
I don't know the microcoding is necessary, but like I understand what he's getting at. It needs to be fast. He's saying that all this stuff needs to be modifiable and fast at the same time.
Retrograde here is really back before 1965. But it helps to have been in computing before 1965 to see it. Because today, for most people, it looks normal.
Right.
And from my standpoint, my goodness, the normal, like before 1965, there was a computer called the B5000, which, believe me, every one of us that runs higher level languages would much prefer Intel to put on their chips instead of having to emulate it as we do. Every byte encoded virtual machine in the world is imitating in software this thing that was directly in the hardware of a machine in 1961. And this is why I say we don't have a field. The reason we don't have a field is because none of you know this. And if you're in physics and you didn't know about what Newton had done, remember Newton was 400 years ago, and the physicists make damn sure we know what Newton did, and they should. But computer people, when they teach other computer people, they don't make you know what Bob Barton did or what Engelbart did.
I try to, but let's keep going.
When I was traveling around in 2004 giving talks, I got a lot of pushback when I said, well, maybe computer science is still an oxymoron. I've seen the, you know,
well, anything with a science on the end of it, come on now. No.
Perlis would have thought that was really funny because that was the whole point. It was an aspiration.
Right.
But today what I got is from every computer science professor, bullshit. This computer science is real and it's what we're teaching. That's a field that has failed. Absolutely failed. So So what I started doing in 2004 was to ask computer people the following question. Have you ever heard of Engelbart? Yep.
Yes.
What did he do? Well, didn't he have something to do with the mouse? And then the key question was, have you ever typed Engelbart into Google?
Yes.
You don't have to go to the library. You've got it right here. You're sitting right here. Type his name in there, and what are you going to find? In the first page of hits, you're going to find access to the 75 papers that Engelbart wrote about some of the most profound issues in interactive computing with people. And you'll also find there the videos of the Engelbart demo in 1968, of which next year is the 40th anniversary.
Should watch that because that's where everything's based off of. But it's good to know the history of it. But I don't know if it's crucial, like how that thing operated was key. Now, for Alan, it was a mind-blowing thing, and for a lot of people that didn't compute in computing, it was a mind-blowing demo because it put together, it basically pulled forward from the future about 20 years into the present moment, and people just never didn't even, that stuff was like sci-fi. It was like actually live and working, and people could see how it worked. But I think we already have an idea of what we want. We have to make the operating system now, so these applications are all open, and the whole operating system from the bottom up is also open, running on this microcoded or FPGA type of system where the software is encoded into hardware, so it runs super fast, or runs fast enough so we can do these operations and get this level of interactivity and flexibility into the operating system that exists on the internet. How things are happening on the internet, we want to have it on the device, and we're waiting for that to happen.
And the World Wide Web is still not up to many of the things shown in that demo.
Correct.
And part of the reason it's not up to it is that nobody even knows about that demo. So
Right.
it is impossible.
Well,
for me,
I mean,
having come out of math,
that was just 2007, so we've seen a lot more stuff from that demo actually come into play, because maybe somebody took his advice back then. So I don't know. It's good just to know the history of these things, where people are headed, and what kinds of things people would like to do with these things.
math and molecular biology to take computer science as a field seriously.
Yeah.
The people in it are not acting like it's a real discipline.
Correct.
The real discipline actually builds on the past, and our discipline is trying to build on IQ.
Right. Yeah, it's built on the autist, Spurgy, to know all the technical leak code grinding. That's like, dude, that was eventually going to go out of the way anyway. The people focusing in on that thing is the data structures and algorithms. Like, okay, yes, those are important, but it's not the thing. And people made it the thing, and it's like, that's why we're stuck. And that's why all these operating systems right now, you have to be an autist Spurgy to make this thing do what you want. And we can get past that. It's possible. I know it's possible.
We're like cave people back in 100,000 BC without any real knowledge, trying to outsmart the other flora and fauna in our environment.
Yeah.
And it's worse today because the web has given rise to a pop culture which couldn't be less interested in the past or the
Correct.
future. They're only interested in identity.
Yeah.
So at a university...
Well, that's a whole other set of problems that had nothing to do with computing, but just the atomization of our culture and what's happened. And yeah, let's keep going.
So to me, there's always too much knowledge to teach. So the primary purpose to me of any educational institution is not to teach. That's just being completely arrogant to think you can teach. The purpose of any educational institution is to help the students understand where the thresholds are in quality. When is what you're doing below the threshold is basically air guitar. It's got all of the trappings,
Right.
looks like it. When is this paper you're writing meaningless? It's got all these mathematical symbols in it,
Right.
but does it have anything to do with computing? Does it have anything to do with advancing? Does it have anything to do with inventing computer science like it should?
No. I'm going to read some of this chat right here. So let's see. Let's see one here. Read something Taiwan about networking transistors, advanced CFET inverter by stacking vertically. Yeah, I mean, there's a lot of things they could do to make these devices supports an architecture that Alan Kay was talking about. Because that's what they did. They did it at Park, so I know it's possible. And that was 50 years ago, 40 years ago. Come on, we can do stuff. It's just there's too much money in the current thing. There's too much money been put in that for them to change. It would be they think it's too costly to change direction, but they did it 50 years ago, 40 years ago with no problem. So it's just the will. Saying the future of computers studying biology is also saying that the step change for computers, there was no center, basically saying we're in a Barstool Galactic timeline where these black boxes, this is keeping the progress back, having these OSB black boxes. We have to preserve the audience and preserve the audience. Yep. Joe F says that. What's the next thing? I'm trying to get to the future. So the next thing is going to be an operating system like Alan Kay kind of demonstrated with the small talk, where you have these self-contained little objects that do things that only messages come in and go out through an API. And if you stick to that thing, you can have these structures within structures within structures within structures, and they can live anywhere and operate anywhere and run anywhere. And it lets us have this containment and complexity reduction, just the same way as you calling in a service or going up to Google, and you're going up to Google. You don't know how Google works. You don't care, but you're calling out and having it do stuff and getting stuff back. And we're talking about doing it at the operating system level, where people have the ability to write these applications and change them for their own purposes at the operating system level, which is pretty amazing. And that's what they were doing with the small talk, so it's totally possible to do. And it was running, I mean, it was kind of slow back then, but that was 50 years ago, 40 years ago. Oh, we could totally do it now.
And if it doesn't, it's the job of the university not to compliment the student and the professor, because now they're going to get tenure, because this is their 10th paper.
Right. So they got it. There's a bureaucratic system that's part of the academia. They plugged in this computer science thing into how the other systems are running, and they're kayfabing and playing house by publishing these papers with all these symbols, but they're not addressing what the anthropological problems that Kay's talking about, and these dealing with the complexity problems that we're dealing with as developers. The things they're way too complex now. That's why the AI has been a godsend, but it's just a stopgap. We need to actually make the thing below, what the AI is helping, the thing below here, less complicated and more standardized, so we can use the AIs to help us write these applications and modify these applications for us individually or for people. So that's what Alan Kay's talking about.
But to say no, quality standard is here. Below this, it's not a real discipline. It's not a real science. It's not.
Well, who's going to set that up for the bureaucrats? See, he's just trying to get us back to the academia, and I think academia is cooked. They've gotten so cushy, and they think it's so comfortable, and they think the status quo is fine, that it's not gonna come from them.
Software engineering below this, it's just bullshitting around.
Right.
It's just going through the motions.
Yeah, that's most of it.
So the thing that,
because it's so hard to do something real, because it's most of the time it fucking fails, as he brought up earlier. So it's like, yes, this is a challenge, but you're also asking people to do something that may not result in success, and some people just don't got time for that. They got to make money and pay for rent and try to buy a house in this inflated environment. It's like, let's keep going.
to me, the biggest difference I believe I see, I could be completely wrong here, but boy, the ARPA supported universities in the 60s, that was their deal.
Right.
It was all about when an idea really constituted an idea, and when, like,
Right, but that was a moment in time with all those pressures, the Cold War, nuclear war, survive nuclear attack, expand the mind, get ourselves out of this situation. So there was this impetus. It's like, any way we can get out of this, we can. So, and then Alan Kay comes along and goes, I got some ideas, and here we go.
you couldn't get a PhD in the ARPA community in the 60s without advancing the state of the art in some material way.
Right.
They just wouldn't give them out for any other reason.
Right.
I mean, what if that were made a criterion for PhD?
Yeah, I thought it was a criteria. Whether or not that's not the criteria, it's just bullshit papers with a bunch of symbols that may not even make any sense, that nobody fully understands.
Have flight from the universities. I wish we would, because I think all of the computer science departments are too large.
Yeah.
In the late 70s, there was a huge...
Well, there's not that it's too large as they're not doing. They're just the bureaucracy. I think he's saying it's a bureaucracy, so they're trying to check boxes now. They're not trying to actually do what Alan's talking about, like invent these new technologies, new techniques, basic research
huge battle
into what humans want.
in the ACM. Some of you may remember it. You might remember it. And the battle was about what should the undergraduate curriculum be in American colleges and universities. because remember, there are only a few places that gave out degrees, but there are 4,000 degree granting institutions, and they are all starting to get interesting. So in the late 70s and early 80s, there's this incredible battle, and from my standpoint, the bad guys won, in that they went all the way back to, basically, to Algol, Pascal in this case, to
I remember that. I remember having to do that.
algorithms and data structures, and
Yep.
completely omitted the idea of the internet, that its systems were starting to become much more interesting than algorithms. And systems thinking you don't get to by doing algorithms.
No.
It's much easier to do algorithms in the
Leak code. That's leak code grinding is the algorithms, the instructions. You don't get the higher level systems thinking, which is now the most important thing. The leak code is pointless. I mean, yes, you still have to know it. You still have to understand how that stuff works. You should be able to read the leak code example, understand, like go through it and figure it out. Yeah, you should be able to do that. But like, is that the thing? Is that the job now? Nope. That's gone.
context of system thinking. Some complicated thing, but trying to scale up algorithms, you get 100 million line operating systems like Windows XP.
Right.
You just don't, they're just two different paradigms.
Mm-hmm.
The big one includes the smaller one, but not the other way around. And
Right.
so this thing actually, I believe, changed computing history, because people started turning the curriculum crank.
Yeah.
And to this day, I was asked a few years ago to look at both AP and the undergraduate curriculum standards in America by the National Academy of Engineering, and boy, it looked awfully familiar. It looked a lot like the kind of programming I did in 1963. Yes.
Yeah, it really hasn't changed much. As much as they say, "Oh my God, it's the most amazing," that's like still not this. It's still based on this old, decrepit stuff from 50 years ago, man. It's time to let this stuff go. It's time to let it go and start something new. Not Linux. Something new. Something based from the bottom to the top that takes these ideas into consideration. Not black boxes. Jesus Christ.
So, what you're saying sounds to me like something that I've often thought is that we're maybe trying to teach the architects and the stonemasons in the same classroom. And I'm wondering, and that costs us a lot in terms of teaching outputs, if we're teaching individual technologies and teaching the skills to be professional programmers rather than perhaps researchers. So I'm wondering, what would you think
What is that? What does that even mean?
about the idea of teaching professional programming?
What is professional programming? Well, I've heard this stuff. People talk about that. Like it's like an accounting thing where there's a set of rules that you can just follow and have check off the boxes and you're professional. No, I don't think there ever such a thing because it's art, man. It become obvious that computer science really isn't this technical thing. It's like it's this artist thing, nuance. Finding product market fit is the hardest thing. There's a bunch of applications out there that have no market fit that have been programmed perfectly and professionally, but nobody uses them because they're not fit for purpose because they didn't take into account the human factor of anthropology. So this whole thing about wanting to turn this thing into a professional thing, I don't know if it can be. I don't know if you ever can be, because how do you be professional and you're serving some new market in a nuanced way? How is that going to be professional? Like, I just this push. I understand the impetus, and maybe certain practices may have to have that, but the entrepreneurial stuff, you're watching this channel, just trying to entrepreneurial stuff. I don't think that's like, can you get a product to market that meets the user demand enough to pay for the effort to keep going? Then you were professional.
As a vocation and teaching computer
Yeah.
science at university.
Well, what's interesting that historically that's the way so when I started programming, it was in 1961 in the Air Force. And actually my boss was a woman, because you may not know it, but a very large number of programmers in the 50s were women.
Yeah, so that was just all the way up to the 80s, 90s, because I had a bunch of bosses, a couple bosses that were women. So yeah, it's pretty normal.
They got pushed out when it became a popular profession. But it was actually, and in Japan, it was a low-class profession for quite a while. So so my boss was a very talented woman programmer. And it turned out that a programmer in those days was a person who made flowcharts.
Right.
And the person who wrote the code was called a coder.
Mm-hmm.
So I started out as a coder, implementing other people's spreadsheets. And this was a predominant way of going on. So the architects were one group of people that were figuring out how this stuff would work, and then they would have a bunch of people who would write parts of these things. But I think that if you look, let's look ahead towards a benign future. So the other way of looking at it is, wait a minute, why shouldn't architectures need to be debugged also, right? Certainly nobody in this room believes in specifications that you can't run.
Boochie, 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 Booch. Booch, he believes that you can run it from the spread. You could do the flow chart to code. Boochie, 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 Booch.
I hope, because just think about it. Anything you write in any language is
Gary Booch. I think it was Gary Booch, right? Gary Booch, UML. I think it was Gary that did the Gary. Yeah, oh Grady Booch. Now he believes you can take UML. I did a video about that. It'll be good. If it didn't put it out yet, it'll be in the next upcoming videos. Let's keep going.
It's going to have bugs in it. So, and so the question is whether you can make up an architecture that is simply the prototype for the system, and what you have instead of architects and programmers is you might have something more like architects and optimizers.
There we go. Yes, the architect. You build it up. That's your MVP, your proof of concept, and then you optimize it. That's why I talk about adventure-driven development. That's how the best approach. I think that's what he's talking about. So first you architect it, and then you have somebody. So he's trying to put those two together. I don't think you can put them together. I think you got to do you can architect it, and then you write it, and then you do try, and then eventually get to optimization. So maybe that's what he's talking about here. But I think those are definitely two steps for engineering wise. Let's keep going.
I believe there's a difference between design and optimization. And
yes, for sure, 100%. I'm glad he's saying that. I didn't know I thought I came up with this. No, there's definitely a difference between design and optimization, right? Yeah. Getting your MVP, proof of concept, that's your design. Seeing if your design is even fit for purpose for your customers who you're building this thing for. It's not just randomly throwing shit out there. You have somebody you have in mind that you're trying to solve their problems. Keep going.
It's hard to do both at the same time.
Let's see, I do it. That's so awesome. Difficult, yes. It's like, don't even try. I say don't try. I say don't try to optimize and find your product market fit at the same time. That's just, you're gonna kill yourself. Yes, you're not gonna get one or the other. So you're gonna lose both. You got to just pick one. You're gonna find the product market fit, and then you optimize.
Once you put your optimization hat on, it is awfully hard to design.
No, yeah.
You're just in a different world.
Exactly. Don't even try.
One of the 12 principles, by the way, in this thing is to make a system in which the meanings of things and the optimizations are 100% separated.
Yeah, that's the API and the implementation. That's what he's talking about here. The outer ridge where you're talking to this object thing with the messages and whatever things, and then this API is going to define an implementation that may change, right? The implementation may change, but the API is not. It should be more stable than the implementation. That's what he's talking about right there.
And to make that work in a practical way.
Yeah.
So that you should be able to write an entire system in terms of the meanings you intend for it, and to be able to debug it and check it out. Maybe you're doing it on a piece of hardware that runs 1,000 times faster than where you're eventually getting to, but basically to make that part of it stick. I don't know what the answer is, but I think that, to use your metaphor, computer science has almost been colonized by the stonemasons.
Yeah.
In the sense that they are in every university department in the country. I can't identify too many architects in academia today, because architects do architecture, and where are the
He's talking about the technicians have taken over the computer science. He says this anthropological track that he's talking about, the making these computers for people. That part has been lost. So he's saying there's no architects. It's just these people who know to hold all the bits and bytes to, and that's important. I'm not saying it's not important, but it's not the thing. It's like if you've noticed that we've pretty much, all that space is pretty much filled with like what you want to do with these devices and how you access them and all that stuff. But the application for a particular niche customer, someone in mind, how you present that to them, that's not mentioned at all in these ed school. It's not mentioned. They don't even talk about it. They don't even know what that is. Like, what are you talking about? That's not how programmers talk.
Academic institutions today, they're actually making things that require architecture. Architecture is not a theoretical deal. You have to make it in order to understand it. So I'm not sure that
well, it's theoretical until you put it into action. So you're fitting it for some purpose. Then you have to, that's when the rubber hits the road, right? Then it's when your ego gets shot down because your idea is your experiment failed. My experiment failed. I'm bad. It's like, no, that's the journey. He's like, iterate. Then a lot of it's like having something that you want to dick with enough to put the effort in to do it. to go through all the stuff and go through all the failures. Not failures, the experiments that didn't work out like you thought they would.
But one of the maxims is that architecture dominates materials. So if you just take bricks as they come, you get walls and piles of them, which eventually become pyramids and things. But the arch is an unusual organization of bricks, hard to think of. The Greeks were very smart and they didn't invent it. And so literally, arches give you architecture, right? Architecture means the making of arches. And
I just got that. I didn't realize that's what it was. Wow, okay, that makes sense.
I would say that 100 million
Making bridges.
line operating system is building something without an architecture,
Right.
because it's just aggregating. And once
Yes.
the big problem with building a pyramid with arches and without arches is not just the 1/1,000,000th of material you need if you make the pyramid out of arches, but it's the pyramid with arches is also reformulatable, and the one without it is essentially not. Right? So all of those things I think are really very important. But I'm not
Reformulatable. What the hell does that mean? Reformulatable. Reformulatable. Reformulateable. To formulate again. To formulate in a different way. Okay.
is essentially not. Right? So all of those things I think are really very important. But I'm not sure you can teach it as late as college,
Right.
because again, it's a form of
You gotta be playing with Legos. Your mom has to give you a Lego budget when you're a kid and let you play with electronics, and let you play with, budget for electronics and play with these little toys together. Maybe a Ben Eater subscription. Go through that, the whole thing, because he's freaking awesome. You really want to know how computers work? Oh, yeah.
I think it has some paradigmatic things to it. It's a way of looking at the world, and if you want people to look at the world in ways that cave people didn't look in the world, you need to start early with children
Yeah.
and get them to have some appreciation for scale, for example.
Yeah.
Yeah.
Yeah, building Legos gives you an appreciation for scale. Mm-hmm. Because you're going to try and build something that goes way out, and you're like, oh my God, this is like, oh, how far can we go? And you're going to realize there's limits, and those physics comes in, all this other stuff that you don't even know you're taking it in by playing with these damn things.
Yeah.
Have you talked to Jeanette Wing, or not just her, but a number of different people have proposed this computational thinking
Yeah.
as a way of something we should be teaching, and I think their view of it is that the great inventions of computer science that we had over the last 30, 40 years, whatever, those ways of thinking ought to be imbued to everybody. But that seems to be the opposite.
Most people aren't interested. They want to use your stuff. But see, this is one of the things that like nerds and honest that we think that everybody is as interested in this shit as we are. No, they're not, man. They got other things they want to do. Now, the people that are interested, that we should be available for them and not do this gatekeeping thing like, you're not good enough. Like, that should not be a thing, but like, it is. And that's just what we have to deal with. But like, everybody, okay, I mean, not everybody. Most people don't want to dick with this. They want to play and listen to music and watch TikTok.
What you're saying our field is garbage, and we should be, and nothing of value really has come out of it. We're all going the wrong direction.
I don't think Alan's saying it's garbage, but you've been on coast since the 70s, so it's not really garbage, but it's more like grift.
No, here's what I'm saying. What I'm saying is I love computing more than anything else. Why would I be here?
Right.
I love it. It's one of the best inventions human beings have ever come up with.
I agree.
So there's nothing garbage about it.
And most dangerous, but let's keep going.
But I feel really sad, to a depth I don't want to confess, that people aren't taking advantage of the wonders that it has and are not.
Yeah, that's what I'm saying. This is what Alan Kay's like. He's just sad that we were stuck in the 70s, man. We're stuck in 1976. We need to get out of that shit, dude.
Even curious about the wonders that it has.
Yeah, nobody's even cares. Like, oh my God, this is the best. Like, no, mate. We haven't seen it yet. We've seen this demo, a very good demo of what's possible.
I feel profoundly lucky to have been in my 20s and 30s when I was.
Yeah, man. He got the full. I mean, now he created this environment for himself, but yeah, he had a good dose, solid. I mean, we're still using all the stuff today that they came up with then, so I agree.
Because the other thing about it is that the field isn't there yet, and what it means is that looking into the future isn't just a bunch of slogging and making footnotes on the past.
Correct.
It's not even close to that.
Yep.
But in order to, in a sense, McLuhan said, we are rushing faster and faster driving faster and faster into the future, but steering only by looking at the rearview mirror.
Right.
And another wonderful line he had was that he said most people can only deal with the present in terms of the past.
Yeah, well, what else are we supposed to do with it with? McLuhan? That's like a Zen koan. People can only deal with the present with the ideas of the past. It's like, well, what other ideas are they gonna have? Well, okay, so I guess his point is like people like him come along every once in a while and go, hey, you guys are kind of missing out on this other thing over here. And he's like, shut up, we're making money.
But artists can actually see a little bit, and the reason is the present.
Yeah, artists, okay, yes.
We are not aware of how many things we've normalized inside of ourselves that we take for granted.
Yeah.
And artists are people who...
But how else would we? Unless an artist comes along, some visionary that goes, hey, dude, look over here. People go, shut up. But some people go, oh, look at that. Well, that might be something right there, Alan.
can see that a little bit. They can see it a little, because they can see this is what they report in their art, is what is actually going on.
Yeah.
This is what McLuhan was reporting, was actually what was going on, not what people thought was going on.
Yeah.
And because of their ability to see a little bit of the present, they also see a little bit of the future.
Mm-hmm.
Susan Sontag said, all progress starts with our refusal to accept something about what's going on today. So
dissatisfied.
part of the deal is...
And, okay, so there's dissatisfied, and then there's a whole bunch of people that are dissatisfied, and they're complaining. They can figure out exactly what the problem is and all the different slices of it and aspects of it. Okay, but then there's other people. There's like another tiny little group of people who can actually put their time and effort and energy into figuring out these damn things and then providing a solution to those massive group of people who would get benefit from that. Which one do you want to be in? Because it's a lonely path. It's a hard path if you're trying to go into something new and you're trying to provide value for some customer and you haven't got there yet. Oh, adventure! You're on the trotting up the mountaintop on the side of the mountain. It's cold, it's windy, it's raining. You're running low on food.
is to just see. I don't believe we're trapped for a second.
looking for the cave entrance, looking for where the dragon's treasure might be. You don't know if you're going to find it or not. Oof.
Because, for example, when Nicholas Negroponte decided to do the $100 laptop project, a bunch of us got together and we raised $20 million, and Nicholas went out and started getting countries signed up. And the truth about laptops is, I don't know what kind you have, but all the HPs, all the Dells, half of the Sonys, and a third of the Macintosh laptops are made by a single company in Taiwan called Quanta. They have a different factory for each one. You have to have a different badge to get into each one. But they make 42% of all the laptops in the world. And if you want to make a laptop, or any university wants to make a laptop, you just have to get on your CAD. Much easier now than it's ever been in history.
True. Even easier today. That's true.
The whole damn machine before you have to build a single atom of it. Take those plans over to Taiwan, and they will build you a machine.
Mm-hmm.
I mean, when we did the...
Well, but there's a budget. Yeah, I mean, come on. It's not like... I mean, the PCB way, the whole thing, that whole movement's awesome. But I haven't seen people build a whole... I mean, the Raspberry Pi, I guess, is that kind of technique. But we still haven't seen the operating system stuff, because that's a hardware part of it. But the software part is the part that Alan Kay and I are referring to. That's the real limiting gate factor right now.
Alto, we had to set up a production line. We could build maybe 3 Altos a week. It took us a long time to build 2,000 machines, but today, Jesus. And that project started in January 2005, and we made 1,000, and we had to invent a new kind of display for it, because the way displays are done today are too expensive, and they don't work in bright light and in darkness. So we had to do a whole bunch of things. By the way, a very, very talented woman scientist is the CTO, Mary Lou Jepson, a true genius, was able to invent this display, engineer it, and in less than 2 years after the $100 laptop project started, last November, we ran 1,000 machines through the factory with 0 defects on the display. First, never been done before in history to do that, and it was like 15 or 20 people.
And they're hand cranked.
No, they're not hand cranked.
No, they're not.
But get on the internet and find out what it is today. You're dealing with stuff
I'm
from...
talking about the UN deal with the
Yeah, that was like in 2005. This is 2007.
Sorry.
Yeah, that was a bit of a gimmick,
Yeah.
but the cranking is now, as we thought it would be done with a treadle, because that's most things are treadle powered in the third world, and there's also a really beautiful, efficient thing like this that has a flywheel that will generate. The $100 laptop even with
Generator.
the display lit draws less than 2 watts. The display lit and the radio goes 24 hours a day, so the network, it acts as a node. It's actually like a radio version of the ARPANET. And so even when the
That's
machine is
cool.
off, it's acting as a retransmitter
So
for
it's
the other
a
machines.
decentralized ad hoc network. That's cool.
Mesh, but I mean, it was not a hard thing to do. It was like 15 people to do it, and some willpower, and basically not saying we're trapped in X, Y. Trapped? Come on. This is the easiest time to make anything in history, whatever it is.
Mm-hmm.
You can make a jet engine here at Carnegie that would really work if you want to.
Mm-hmm.
There's nothing you can't do. But the problem is nobody wants to do it.
Right.
That's the big, yeah.
Because it isn't low hanging fruit. It hasn't big bang, bust up $1 billion thing. Yeah. So without that tinkering spirit, we don't get the next level tech. So without the building the thing just to understand and build it just for the sake of building it, just to try, we don't get the next tech.
When you mentioned Neil Postman,
It takes people risking doing adventure. And but the thing they're talking about for this operating system, it's going to take 20 or 30 people behind someone like him that can say no to a bunch of stuff and set the vision properly. It's going to happen.
I like got excited.
Okay,
Then
well,
you mentioned
It has to happen.
Amusing ourselves to death, and I'm more excited.
Just when.
So I want to bring up E.E. Cummings. Okay, because I think of E.E. Cummings as a Catholic.
Nice mic work, guys.
And I think what he did with 10 lines of nonsense and a couple of
Don't
comments
pass the
and
mic
backgrounds
around.
to get
No.
someone to actually understand a big idea is, like, we have so much communication, we have so many programs that do the same old thing over and over. It's boring to use a computer. But if the computer could be somehow more integrated into life where it's actually useful and more intelligent and more able to help us arrive at these revelations, so to speak.
yeah.
And I really think some kind of a study into what makes a person get it as opposed to not get it.
Yeah.
When they look at something by E.E. Cummings, just as an example,
Yeah, well,
is a kind of direction that
He-
a person
he and-
wants to go in, but poetry is not promoted in the community.
well, this is why McLuhan was famously difficult to understand by most people, because he used a similar technique, the same technique that Zen uses, which is to express things as paradoxes. And so if you have two things in opposition, you can stay in 2 dimensions, or maybe 1 dimension here in opposition, keep them in opposition, or you can find another dimension and suddenly you get a nice thing like an arch. So a lot of things that are paradoxical are worthwhile mulling, because usually they're an escape into a different place where they're not paradoxical at all, but they actually work together in some way. And this is why, basically, I respectfully disagree with what you were saying, because I think that essentially what's happened is the theory about normal and also the economics involved.
Economics. Yes, that's it.
Like, it wasn't that long ago that researchers at Carnegie and MIT and other places were sitting down to machines that cost $80,000, $90,000 called workstations.
But there's only 50 or 100 people with that thing, so it wasn't. Okay, keep going.
And they got to peer a little bit into the future on those workstations
Yeah.
for a bit. But basically, the economics now has gotten everybody to not be willing to pay even 1/10 of what they're willing to pay for their car, for their computer.
Mm-hmm.
Now, if somebody would make a computer that was actually 20, 30,
I remember paying thousands and thousands of dollars for these damn things. When they were thousands of dollars was like a lot of money. Oh man, let's keep going.
$30,000, like my car, I would buy it in a second. I want that factor of 10 because it will help me in the future. But so here's an interesting thing for people who are, don't want to do this all by themselves. Chuck Thacker, who is the great, should be given a Turing Award, but the ACM hates hardware people. Never given a Turing Award to a hardware person. Even
Wow.
Maurice Wilkes, who was a hardware guy, got it for a software thing. So this is absolutely outrageous. But Chuck Thacker was the architect of all the computers at Xerox PARC, and he's been working with Dave Patterson. You've heard of him. And this summer happens to be maybe the turning point in field programmable gate arrays. So it's if not, then next summer. But we're right at the cusp where these things are
I think they thought they were going to be more effective than they really are. Let's keep going.
going to become a huge weapon and within reach. And Thacker is designing a modern-day Alto computer,
Yeah.
which probably half of it will be field programmable gate arrays. But our definition of a research computer is that 2 cubic feet of the fastest hardware on the planet, constant, right? So every 3 years you have to clean out the 2 cubic feet you got and put in a new 2 cubic feet, and then you can actually do research. And so Thacker is arranging so that this machine is going to be made by a Silicon Valley company and will be available for sale. For
I don't
people
think
who want
I don't know if that ever went to production. I never heard of it. Let me know in the chat if you've heard of it.
to actually do research. This is part of a discussion that a bunch of us have been having over the last bunch of years. Is, hey, where are all the wedges? Well, the big wedges are in people's minds. People just can't imagine what computing can be if it isn't like what it is right now.
Right.
But the other wedges have to do with, in order to get ahead, you have to have some way of peering into the kinds of, you have to have a way of making systems. So like another one of the things that we're planning on doing with these FPGAs is experimenting with these thousands of protected address spaces.
That's cool. I'm gonna read some more of the chat here. Okay, what's next? I'm trying to get into the future. Yeah, we are, aren't we all? You're gonna be there anyway. Tim says, so this is just ports and adapters, but the majority of devs don't know how to do this. Correct, Tim. Zashinko says, good thing I'm patient and curious. Just got into computers this year and glad I found out your channel. So much insight and I can place all my stuff to help. Yeah, Zashinko, make sure you look at my how to program from the ground up, Minimal BS. It gives you like a preview of all the things you need to learn, what kind of paths you can go down, and a couple different gotchas with the class-oriented programming versus back to object-oriented programming, which is what Alan Kay is talking about, and the difference between those two. And also, just assembly language isn't scary. It's quite simple. It's nothing to be afraid of. I wouldn't want to write in it, but how it works, it's not that difficult. Okay, I think that's fintech. Zashinko says, I think that's like fintech. Cinco says, I doubt it. People will be bored once you hear the word professional. Maybe. Tim says, professional programming is a deadline programming. But best part is that because the developers don't understand systems, they can't pivot to something meaningful. Oof, Tim. Zashinko is too poor for Legos. I had MedX. Whatever it is that gives you like that tactile building something up and from your imagination, that thing, whatever device, whatever Lego you want to use or the cheap stuff, doesn't matter. Just that's the thing. Congrats on 2K. It's a lot, especially for tech channel. Yes, you're seeing. Yes, my tech channel is very weird and niche. Let's keep going.
So that you can actually build a thing that is not an operating system, that is much more scalable and flexible, et cetera, et cetera. Yeah.
Next question. Unfortunately, we're running out of time.
I agree with a lot of the things you said about there being a lot of silly ideas in computing that's currently being used, and there's a lot of better things to be done, and there's a sense of being trapped in those conventional ideas. But as a researcher and seeing research in industrial labs and academic labs, it seems like the biggest force keeping the sense of entrapment is mostly marketplace forces.
Right, exactly, because people see the big money and they expect the big money for anything that happens, and they expect to have the returns that they've already had before. Otherwise, they don't want to get involved. So there's a lot of low-hanging fruit people. There's a lot of people that only want the easy low-hanging fruit that the guy got 3 years ago. It's like, well, that doesn't happen. That's not how things happen anyway. And that low-hanging fruit guy, he was in the field, he was in that farm, in that field for weeks and years before they showed up and plucked it. So there's other low-hanging fruit available, and it's that your niche customer, your niche solution, and you being the one that finds it and do the product market fit, somehow get a little proof of concept and some slice of that thing to show that your user, that you mean business, so you're not just screwing around and goofing off. So you can get them, and then you get to the feedback loop going, and then you're off to the races.
Like just what's commercially viable. And so even though it's
right, what's commercially viable, exactly. That's how all this stuff's run. That's why all this stuff starts out adventure driven. It starts out with someone having a crazy idea, or there's like a set of forces that happen around Alan Kay, around that time in the 60s period with ARPA and DARPA, that there was other forces available. Right now, it's all going to be adventure driven, and it's going to be the kind of thing where you have to kind of dink around with it on your own until you got something close to a solution that a user will be able to pay for, some customer somewhere to pay for. That's all it is. That's the game.
Research, I saw a bunch of ideas which were great ideas, but they weren't being adopted in the product because they wouldn't sell or they're too experimental.
Yeah, but
What's your thought on?
Well, my question is, what does research have to do with marketing?
Well, money comes from.
No, but what does science have to do with marketing?
Science needs money to run.
Yeah.
Because
and-
we've been trained. Because we've been trained for a long time that these computers better make money, and you better be looking for $1 billion exit, otherwise it's not worth messing with. And that's the people that are most of the people are into the computing or have been into it for the last 15 years or so. And maybe that's changing. You know, maybe the age of the artist, nuanced developer is now dawning.
Does it need it from companies?
Or it's just the phase. This is the phase of the economy where adventure-driven stuff is the only way out. You're not going to get a job anyway in a big company, or maybe you will, but you're probably not going to like it if you're watching this part of this channel. Not to say that I haven't done that, and you have to do it for a period. You might have to do it for a period of time. Maybe it's good for you to go do the 2-week ticket sprint environment and see what that's about, and then realize what it is, and then realize that you're probably not going to be happy just keep doing that. Some people are. Don't get me wrong. Some people are totally okay with that. I've met lots of people that are like, that's if I could go in, check in, do my 2-week sprint, check out, I'm good. But your days are numbered if you just think that that's what the job is. I don't know.
Well, I mean, especially.
Well, it's not a real look. It's not a real source of it if there are too many side conditions. If the side conditions take the science away,
Right.
it's not actually research money.
Yeah. Right. So his whole thing is like the research. We're not gonna know. We don't know what we'll get at the end of the thing. We probably get nothing. And if somebody's like, okay, I believe in you, go try it, and we'll see how far we get. And that's what Alan's saying. It's like, we don't even know how far we're gonna get. We don't even know if we're gonna get far. All we can do is try, and we can look into the stuff. And Alan's like sick of talking about this. Is like, dude, not everything's gonna have a dollar sign at the end of it. I know, but this is all the stuff that we're using right now, ARPANET and the internet, and it all happened in a completely different way. People just plug money on it and didn't know if it was going to work or not, or going to be a thing or not. Okay.
Right?
But there's also the prospect where, the aspect where you have a good idea, but it's too different from what's existing in the market, so it doesn't succeed, essentially.
Yeah, but okay, so I think it'd be worthwhile introducing people to scientists of the past and why they did science. Because I think, see, I persist in using the
They were all adventure driven, by the way. Just spoiler alert.
actual definition of science for science, and I refuse to admit a different definition for science as applied to computer science. And believe me, science has to do with advancing knowledge and and unearthing powerful ideas.
Right.
It happens to have benefited people who like money incredibly,
Right.
but it has nothing to do with them.
Right. So that's the thing about Alan. This is why Alan's different. This is why Alan is like a really different guy. He talks about the human side of the computing, not just the big dollar sign market domination. We got $1 billion evaluation going to go public next year. He's like, I don't care about that. Fireworks are going in. I don't care. Alan says, this is not the important thing, man. You're missing the point. Missing the point completely. Let's keep going.
Nothing. I think you might be talking about engineering.
Right.
Well, for example, if you were talking about this distributed operating, or lack of operating system, distributed services type of environment
Yeah.
on a computer, the installation of Microsoft Windows will prohibit such a system being.
But I couldn't care less, because
I love it, dude. I love Alan. He just cuts right into the thing. Yeah, look at those fireworks outside. We'll pause, listen to the fireworks go off. All right.
what I have to do is to make a working version of this thing that,
Prototypes are easy, or relatively easy.
okay, well,
It's in terms of like having improving the state of computing in the world and its perception.
well, I have to get you to lead me to all of the interesting prototypes you know about.
With that said,
So I think I had this conversation the other day when I was at UCLA with a kid who kept on using computer science but was really talking about engineering. It was just a word to him. It never occurred, he didn't actually understand what science was all about, and that's part of the problem, is that maybe the final word is we've let the imposters into the temple.
Imposters are in the temple. Right. Well, it made money, so it made sense. Let's keep going.
You know, we've gone to something that is more like a Christian Scientist hospital.
Mm-hmm.
You know, it's
Yep.
That may be the last word.
and there's nothing more uncomfortable than being a physician in a Christian Scientist hospital.
Mm-hmm. Yeah.
So with that said,
All right, thanks, Alan. You're awesome. All right, let me see if I'm reading more of this chat while the fireworks go off outside. Let's see. Okay, Carson Human says, "What's up, Chris? Love your commentary, Among Us." Okay. All right. Well, I appreciate you guys. I appreciate the chat, and thanks for hanging out for the last 2 hours. If you've been here the whole time, and I hope you learned something. And I'm a big fan of Alan Kay, if that wasn't figured out by now. And I will talk to you soon as the fireworks go off.